Hello, and welcome to another episode of Reasonable Coding. I have Fernando here once again. Hello, Fernando. How's it going?
Hello, all good?
Yes. And this is episode number 23. We're going to be finishing up the design system that we started a few episodes ago. I think it was episode 19 last time you were on.
I do not know that by heart,
Okay.
but I believe you.
All right, that's good. We don't need to be precise there. However, we will like our design system to be very precise. So hopefully we'll make it up on that end.
Cool.
And so I was saying, today we'll try to finish up the design system that we originally began. It's a design system that we started working on here live for a project called TLDR. It's a small website that lets you find essentially community compressed or community digested pages, TLDR, descriptions for commands in Unix and Linux and macOS, and I think Windows as well. So for example, if we were to look for tar, which is well known for being confusing to use, you'll quickly find that you have these recipes for for executing different things, right? Like creating an archive or extracting the visit archive into the current directory.
Just struck me that page should probably include the XKCD about tar.
Yeah, that makes a lot of sense.
You can ignore, you can leave more pages as just plain, but that one is just too good not to have the Easter egg.
Yeah, I was thinking of that. I couldn't phrase it properly on the fly, but it makes sense.
Just in case there is an XKCD about the tar command, somebody is prompted to ask to make a valid tar command in 10 seconds, otherwise a bomb is going to go off. And the person is like, there you go. It's like, I'm so sorry, guys.
I'll live there a second. That's really good.
Yeah. Yeah. So yeah, that I can't help but remember this comic whenever we think about how to learn the tar command.
Yeah. I also think it's a really good example to go to, right?
Exactly. This is precisely what TLDR is supposed to fix for you.
Exactly. Okay, so we were talking a little bit of what we wanted to do. So we're going to write a plan file where we're going to state what we want to do. So that it's completely clear and obvious for everyone that's watching out there. So we began last time with a very thorough description of what is a design system, why does it help, how different approaches to encoding or thinking about it, and we attempted to encode one. Yes. Unfortunately, we ran out of time, and our implementation was left in half. We do have a bunch of code though for it. Yeah. So what should we do today?
Right. So last time we left at the visual definitions of some of the visual components. So for example, the input field, we had a design for it. I believe, yes, it could be good to put it on the screen as well. We had the input field, defined design, defined styles for some title texts and some body texts and some links and some buttons. So all the pieces that were identified as key to make the TLDR happen. And we also had, okay, now you can see it on the screen. We also had the overall layout that we were thinking for the website. So to just do a small recap on the goals and the approach, the design system takes into consideration all aspects of website design, but also things like the communication tone. That is overlapping with brand design, right? When you think about the communication tone and colors and what the colors mean and how they are going to be interpreted, you are diving a bit into brand design, but they are extremely related since every decision taken at the brand level will have consequences, or at the very least should have consequences on the design system. Otherwise, the UI and the experience and the look and feel will contradict what the overall message is what the overall intent of the message is. Now, for TLDR in particular, we agreed that it is a very pragmatic page. The goal of TLDR is to get out of the way, fulfill a purpose, and just be mostly ignored. So we didn't think we wanted to include a very idiosyncratic and full of genuine, unique, crafted brand. We thought maybe it should be good to have a more generic look and feel, something that is very usable.
Right.
That still has internal consistency and is attractive, but we didn't think about introducing some special colors for the accent or special background shapes, anything out of the, let's say, simple typographic design rulebook. We're following a very, very simple and clean approach.
I think it makes perfect sense considering the product that we're building, right?
Exactly.
TLDR is supposed to get out of the way,
Exactly.
so the design should reflect that it should be out of your way when you're using it.
Exactly.
If you're interested in more, if you have an interest in how we arrived to this, I urge you to watch the prior live stream on this. You can find it on, the YouTube channel, which you can type. And I'm gonna do something that hopefully will work, because we just bought a domain for this and we're trying to get it to work. Okay, I do have a lambda here. Yeah, this is a very quirky thing, right? But if you type lambda.tv, it will take you to the Reasonable Coding channel in YouTube. We're yet to change the name of the channel here, but essentially, yeah, chapter 19 was the one. You can watch this. It's about almost 4 hours. You can absolutely watch it in 2x speed,
yes,
or leave it in the background and catch the parts that you're interested in.
Yes.
If you would like us to, we can definitely at some point add markers so you can jump into the parts that you're interested in more quickly. I think that could be helpful, but if no one's gonna use it, then we're not gonna do it. We don't have that much time to invest into this yet.
Cool.
Anyways,
let's do the plug for this. If you are there and you haven't subscribed yet, please subscribe. So if Reasonable Coding reaches 100 subscribers, then the URL can be edited to actually reflect the name.
Yeah.
So that's
it actually already has 100. Yeah.
Oh.
Yeah.
We should be celebrating.
23
that.
minutes ago, I got the notification like, "Hey, 100 subs! Congratulations! Thank you everybody for following. It's been great. It's been a really good season. Let's make it 200 for the next one." All right. Cool. But going back into this,
yeah,
we began with this Figma project where
yes,
we essentially explained what the pages that we were gonna be working on are and what the components that we had were, and we digged a little into different parts of the system that we're gonna very quickly take a look at. If I go into design system, we have the design notes. Perfect.
Yeah.
We built some screens. We took a look at the mood and tonality and expression. We defined some molecules or components, like there will be a search field, the main title, the detail text, an example component. We took a look at atoms. Can you remind us what atoms were? Right.
So this chemistry vocabulary is interesting. The molecule level is what we consider usually a component. So if you think about an input field, a title, or a button, those are the units we think about when we think about UI design. Those we're calling molecules. And the reason for calling them molecules, it's because they can be still decomposed into some parts, but as a whole, they serve as a unit. So that's how the metaphor works. The atoms are the parts of the molecule that are themselves not decomposable. So you cannot really break down an atom into further visual pieces. So in the case of the input field, you have the background of the input field, that is an atom. You have also the text of the input field, that is another atom. You have the border of the input field, that is a different atom. So you cannot break a border into smaller visual pieces. You can break it into different properties. For example, how much radius does the border have, how thick it is, what color it has, what style it has. And those we call particles in turn. So the atoms are in turn composed by particles, but they are composed in a different way than molecules are composed by atoms. Atoms are composed by particles in the sense that they have many values that they group together, but they form a single visual piece. Molecules combine visual pieces into an integrated one. So that's why we have more atoms and molecules and more particles than atoms. We are going into the fine-grained details at each step.
But it could very well be that you have a design system with a limited amount of, short amount of atoms and particles and several molecules, because you have more pages and you have more use cases, right?
Right. What tends to happen is that you try to differentiate the molecules visually to the extent that they start using different atoms to reflect those differences.
Exactly,
So you want the background for the field to be different than the background from the button, for example.
Precisely.
So you start incorporating more atoms like that. But technically, you could have just this really small set of atoms and prepare a lot of molecules out of those.
Right, exactly. They might look quite the same, but they will be different molecules.
Exactly.
So we managed to encode some of these things as essentially Reason or Camel modules and types. The idea was that we would encode the type system and the correct valid combinations of these particles inside of atoms and of these atoms inside of molecules through the type system, so that when you put together a user interface, it 100% follows the design system. And if you don't, then it's a compile time error. We managed to actually get some of it done. I had forgotten about this. It's been a few days since we haven't, maybe a week or so.
Yep.
But the text module, right, seems to have defined main colors, such as black, white, and error, right?
Right.
And a style that doesn't necessarily require the color of the text for all of the variants.
Exactly.
And I see that the variants here, like detail, for example, matches the detail text, and body matches the body text, and we have example, which can be further deconstructed into the code and the title.
Right.
That is not reflected here, but if you look at the atoms, we do have a description example text style and a code example text style. I reckon this example title could have been example description, or the other way around. This will be easier to change, I think. There's no type checking on that document. And what we ended up making is a construction function, right?
Yes.
That goes from a particle of a font size into a text t, which is precisely a value of type text.
Yes.
Now this doesn't actually represent the current on-screen text. It's just a description of what the type system, the design system should look like.
So to go the extra step to get it into the screen, we need a function that in turn goes from this type that has a lot of specifications into an actual DOM element, right?
Exactly.
Or a React component, really. The React component will in turn make it into a DOM element under the hood. But what matters there is that we need to turn it into CSS. In our case, it could be, like, the good thing about this type of declaration is that it's very platform agnostic, so it does not have to be CSS in itself. But we're going to go with CSS. So we need to fill in all the remaining props that we're not really defining there. And some of the props that we're defining there, the values for those particles, we are not actually defining there. So when you see an example of a text that you can have, right, the text detail, we are saying that the text detail has the color black, has the size detail, the weight regular, and the family sans. All of those values comes from our particles, which are really enums. There are some types of all the different values that you can have, but these are not CSS values. We still need to map them into CSS values. So we're going to have this level of concreteness in which we go from the design system representation of the text into the DOM representation of the text.
Exactly.
And this is pretty much what we are going to be doing a lot today, since we want to go from this type definition into actually drawing into the screen.
Precisely. So the idea wouldn't be to try to flesh out all of the design system that we have in Figma, but rather pick a particular element, a particular molecule, a particular atom we could even start with.
Yes.
And take it all the way from this type-safe design system specification to an actual element on a screen that you can interact with.
Yes.
I mean, if it's text, you won't be able to do much with it. But if we picked, for example, the search field, which has an input, then we should be able to type something in it because it should already be an input field in a browser.
Exactly.
All right, so let's see what we need to set up for that.
Yes. So I reckon you're thinking about rendering an atom right now, not yet the entire molecule.
I guess we could start with rendering an atom.
Yeah,
actually, would it make sense to render an atom, since an atom for the search field will be search field text style? It might be that to actually render something, we need a molecule.
So I think the search field is actually a very peculiar case because it's one that requires an input tag inside.
Yeah.
But if you think about the case of the detailed text,
yeah,
then there is nothing weird about it. Like there is nothing in particular. You just need a text type of node and then some styling, right? It needs to be either a paragraph or a span or whatever.
Exactly.
So I think it's perfectly fine to render an atom. I think like the kind of point of the atom to some extent is that the smallest visual piece you can render. I would rather do it with the detailed text than with the search text, mainly because the detailed text will go into simply it will not have anything peculiar about it. It will just be some text tag with styling. The search text, it's a bit more complicated.
Okay, I'm gonna make a space here in the implementation, in the design notes, and I'm gonna title it implementing or implementation, and we can start making some notes about what we want to do here, right?
Yes.
So the first thing we want to do is we want to render an atom, right?
Correct.
And we don't want to render just any atom. Render the detailed text.
Correct.
Text style atom.
Yes.
So this detailed text style, if I understand this correctly, will render just to a CSS, a piece of CSS code, or it could be an object that represents the CSS style, such as a React CSS and JS object.
Oh, right. So there are two parts to it, right? One could be, so it depends on the rendering engine, right?
Yeah.
If you're thinking just CSS, then you could have a pure function that goes from the atom text into a CSS object.
Yeah.
That is a nice function to have. It's a very clean function to have. I have to highlight, however, that for rendering some of these atoms, the platform will require you to spread some of the properties in different DOM elements.
Right.
Which means that ultimately the atom rendering will not be encapsulated with a pure type to CSS function.
Right.
It will require the full-fledged React component.
Okay.
So I see the value on doing this in an abstracted step, but don't get too cocked with the beautiful idea of a pure function to CSS. Because in reality will not pan out.
Right. My question was around if atoms map to some CSS for styling properties, right? Which may not be CSS, could be anything else you're styling with.
Yeah.
Then what we want to render is the detailed text molecule, which only has one atom from the discovery process we did before.
I would say that you can just render the atom to start with.
Okay, so we will render a text style atom.
Exactly.
Okay, so I guess that really, even though we've specified a bunch of atoms in here, right?
Yes.
They're all already encoded in all of the ones that belong to the text.
Yes.
Are already encoded in the one text atom that we have.
And this is one of
that makes more sense.
Yeah, this is one of the powerful things we got out of this ReasonML abstraction. Because in the JavaScript I was not able to do this, which means that they actually have entities for each of those intermediary atoms that we have in the style the style description. So atom detailed text, it's a separate entity from atom search text.
What do you call an entity?
Sorry, a component. It's a separate
okay.
component. It's a construct. It's a construct.
Okay.
Yeah.
So here is just something that will go away when we compile this. Because it's part of the type system.
Because it's part of the type system. Yeah.
All right. So we want to render the text atom then.
Yes.
To do this, we will require the following things. We need to set up buckle script, which should be fairly straightforward.
Yep.
And what else we would need to do? We would need to create, I guess, a text component.
Correct. We need to create the type like atom text to CSS function.
I'm confused. So this text component, right?
Yeah.
Would essentially behave like a function from from an atom in the design system into a React component.
Yes.
So in my head, it will take two things, right?
Internally, it will have this function, but you're right. We don't need to build it separately. We just need to build a text component that takes an atom type as an input.
Okay.
An atom type, is that correct?
Yeah. I guess.
Or it's not a style. It's a style type for an atom. That is what it takes as a prop.
It takes one of these atom text T.
Exactly.
Right. I guess that there isn't really a type for all of the atoms right now. Each atom in particular has its own type.
Right. What I mean is that you have the type style in there, right? That you feed into the creation function. So the question could be, what does this text component receive as a prop? That is, does it receive the style, or does it receive the text T? You know what I mean? Because it could convert it into a text T internally with the make, and then the consumer of the atom has to have even less knowledge about the specifics of the atoms.
So the consumer of the atom won't really see this type. They won't have access to what's inside.
Oh, I forgot that.
It's completely opaque, right? It's exported just as a T. So if you make an atom of type if you make an atom text T, then the only thing you knew is that when you made it, it was a detail, a body, or example, or not.
Right.
Now the only problem with this is that you could pass in you could pass a constructor in, and then you lose the kind of constructor that you were using, because you get a T back that you can't inspect, that you no longer know if you had a main, a detail, a body, or example, or a code, or a example title, which roughly means when you create, or if you create a text, you can use it anywhere.
Okay, I'm not 100% sure I follow. I think it's going to become more clear once we do the implementation.
Yeah, we can do that.
Yeah.
All right, so let's begin from the beginning. Let's actually try to set up buckle script. I'm gonna close this, and I already had installed the thing, and we can just say web, and then theme. I think Reason will be a theme. Sorry, React will be a theme. Cool. And just because there's some incompatibilities between the way buckle script and do module namespacing, I'm just gonna duplicate the model for the design system into the web project. This is not something that you will need to do per se, but in this particular repository, it's sort of necessary. Okay, so I'm copying the design system over there, and then we're just gonna be inside a web. So we're gonna be working in TLDR web. So here I can do yarn. That's just a shortcut for yarn. And then we can see that we have a design system file here, which is the same one we had before. And we can see that we have some components. 1, 2, creating stateless components from Reason React. It has a handle click. We don't need all of these things, so I'm just gonna leave the component number 1 and remove the other one. You can see my computer is churning now. And this is also using Webpack, which I personally do not recommend, but I know a lot of people like it. So I'll just leave it there. And this is just gonna call, render to element with ID, and it's gonna call our component 1. I guess we could call this text, which is the component that we're gonna be building.
Sure.
And we can say, I think it makes sense to do this. And just passing hello ReasonML coding.
For sure.
And we can just say text will be the name of the element in the DOM. So if we open the index now again, and we can remove these things, and we just say text, Reason React, ReasonML coding design system. Actually, TLDR, design system. That makes more sense. Cool. So if we On the right hand side of the screen, which you can see my hands, I'm moving around pointlessly. I'm just gonna begin the build process, calling BSB make world, which will compile everything. We have some type errors that we need to fix. And on a little split that I'm gonna run on there below, we essentially can run the Webpack server. And if I'm not confused or mistaken, there should be a Webpack server. Okay, so yarn server. I think that's how you do yarn things. It's been a while. Is that okay?
That is how you do it.
I'm actually happy that it's been a while, but it's been a while.
Failed to compiled.
Cool. So let's look at the errors that we have
Cool.
here.
Yeah.
The first one is in design system. I'm just gonna pick the one in the middle, the one of the color main. And I think that's because we, at some point here, right?
Are we defining the name twice?
Yes, and which is fine as long as we namespaces correctly.
Cool.
So one problem that we have is that
Right.
one main refers to the particle.main and the other one refers to style main,
Yes.
but we have no way of referring to this type by this name. So what we need to do is essentially not do this local open here,
Yeah.
which is kind of annoying.
It is, because we're going to have to add particle dot to everything.
Exactly. So maybe we can rename main here to be something else. Alternatively, we could use polymorphic variants, where we can just reuse the tags and it should be okay.
As you please. You are the
So I think I'm just gonna do polyvariants.
cool.
Because changing main to something else is just gonna make it confusing. We're gonna have to mentally map that the font size main is different than the style primary, for example, or that they match primary.
Yes.
And I would much rather the computer did that for me.
Yeah.
I think that is the right kind of lazy, but you know, you never know.
I have to say it's a bit tiny bit strange how the like I haven't seen this problem appear in this particular way in other languages. So I think like this represents some learning curve to Reason. It's not a huge deal, but
What in particular are you referring to?
the name clashing of this type.
Oh yeah.
Because it's like you open the module and then you get the constructors right away, and you would expect that maybe you get the types and then you do like type dot constructor or something like that.
Right.
But no, you get the constructors. So the constructors can clash names, but there are legal reasons why you would like to reuse a constructor name. They're kind of like method names. If you think about lists, for example, the terminal case, you always want to call it the same, either nil or whatever. It's a bit annoying to have a like h nil for a heterogeneous lists, and you know.
One small thing here. And okay, we reached the last error, which is that there is in a module called source text.
Cool.
That makes sense because we still call it component.
Yeah.
re source text.re. I'm gonna make one last adjustment to the configuration of the project, and that's gonna be to not build in source, to build everything out of the source. And the reason for this is that I really don't like going to source and seeing 4 different representations of the same file. You see, normally when you build in source, you get the text RE, which is your source, but you also get the text BSJS.
Yes.
And to me, this one is just an implementation detail. It's like a compilation target. So I just send it away. Hopefully that's not going to cause any trouble. I can already foresee that the Webpack config will not work automatically. BSJS. But now if we go into lib, then in lib we have the same files and they're there, right? So let's do the last one thing, and then we can try to leave JS source. That should work. Cool. Okay. So it compiled. It failed to compile the Webpack part. If I rebuild the server, huh? Oh, so sorry. When we renamed the file, we didn't actually change the
import or
the signature.
Oh, right. So right now we're simply parsing the children, right? We don't have any click to handle. If we want to remove that,
we can remove that as well.
Yeah, and technically it should be a text type of component, so it can be a P or a span. So that does raise interesting questions, like should it be a P or should it be a span? Stick with span for now. I'm aware that that is not the right semantic choice for all cases. It happens to be the generic case for text. But if we want to add semantic support for actually having paragraphs and so on, we probably need to encode that in some property of the text component. So you can tell the text whether it's a paragraph or what, and under the hood it will turn it into some platform specific representation.
Right. Like for example, if you're compiling to native with React Native, it would pick text or a sub-component of text that will be specific for like a list.
So, I mean, if you think about paragraphs, right, there is no such such concept in native. In native,
right,
you only think about
no P.
No, there is no P. So saying to a text that the role is paragraph, it's only relevant for some platforms.
Right. Cool. So we have a text
Pixel
component here.
Span style display block. Yeah, classic. Yes.
Is that Pixel Hero?
Yes.
I'm gonna jump in quickly. Go to channel. We should probably be here so we can talk to people.
I'm there.
Cool.
I can work as your operator as well.
Yeah. You're actually moderator, which is cool. Oh my god, Pixel Hero gave us something.
Yeah.
I don't know what it is.
He owns the room now.
Woo!
The channel.
Cheer to take. You own the channel now, you can live stream your own computer. Do it. Okay, so moving forward. Oops, sorry. I destroyed something I shouldn't. Moving forward, the flow will be, we'll be talking a little bit, I guess, trying to make some changes on the left side of the screen, on essentially this side of the screen, right? And if something goes wrong, we're going to be told about it in this side of the screen.
You mean the right hand side, right?
Exactly, the right hand side. And every now and then we're going to check on Webpack to see if it's still alive. Yeah. So what do we do now? Now we have a component that's rendered on the screen, right?
Yes.
With some text. What we want to do is, it's kind of unfortunate that it will not look too different from this.
Well, it could be smaller, the detail one.
I actually zoomed in a bunch just because the resolution, like 200%.
Oh, okay.
So that it's readable.
Fair enough. So, yeah, it's okay. It's okay. It will not be extremely different, but we can check that in the inspection tab to verify how the properties propagate.
Perfect. So I'm going to have to close this and make this a little bigger as well. And I think this will work. We're not going to have a lot of markup. We're definitely going to have some properties, right?
There you go. And by the way, we're going to be doing inline styles only, since those are the ones you can generate with JavaScript.
Right. But we could easily take the design system, right, and compile down actual classes.
Define easily.
By easily, I mean we could have a program that interprets part of your program.
Yeah, so
and compiles it down.
If all the possibilities that you have for the styling of your components can be exhaustively mapped, then you could turn them into classes and convert them into a style sheet.
Yeah.
And that could arguably be beneficial for performance reasons. And I say arguably because the size of the style sheet might be very big indeed.
Depending on the design system. Yeah.
Exactly, depending on how many parameters affect the styles. So essentially, each property of the object that affects the styles can be treated as a separate dimension. in the matrix of possibilities.
Okay. So it could grow really, really fast.
It grows very, very fast. It's actually, I mean, it's exponential growth in the sense that, I don't know if that's the definition of exponential growth, but essentially when 2 dimensions you're saying amount of styles to the power of 2. But if you have 3 dimensions, it's to the power of 3 and so on and so forth.
Right.
So very rapidly your style sheet might become gargantuan in size. And it might be hard for a program to do any optimization on it. So, I mean...
Yeah, because you don't have a way of checking, hey, what combinations of types are not being used.
Yeah. So the right way of think about it is that the style sheet, the statistical style sheet, is the memoization of the function of your styles. Right. So if you think about the function and the memoization of its use case, there is a trade-off in which memoizing all cases is actually more expensive than executing the function.
Precisely.
And this affects styles like everything else.
Okay, so given that we have the component, right?
Yeah.
Now we can start taking some decisions that will definitely impact, let's say, the ergonomics of our design system. As a programmer that is focused on making the views happen, like I need to do my daily job, right? I need to close my tickets, deliver value, and all that crap.
Yeah.
I will have to come up, or rather, I would have to use this text component in a way that makes me sort of safe. So that when I use it, I know that I'm using it with the right styles.
Right.
How will we go about that?
So at this level, at the atom level, atom text in particular, what we need to make sure is that we pass in a value of the atom text styles.
Right.
Since those are the only ways that you can create atom text. So if you go back a tiny bit to the
design system?
Yes. Right. So in line 29...
Remove this stuff that's kind of bothering us right now?
Sure.
Line 29 you said?
Probably not 29 anymore. And there you go, line 35? No, 24. Line 24, right
here.
Yeah, I could argue that that's what we want to pass in.
Okay.
As a prop to the component. Why? Because if your designer tells you this is a detail level text, well, this is what you have, right? You grab an atom component and you pass the style detail out of your mind.
Right. So if we get an atom here, this atom is for the text, and depending how we use it, it will be typed, would be inferred the type, right?
Right, but here's the part in which I'm not sure about calling that the atom, because what you are actually getting is the style that you use to create the atom.
So here we want to get a style.
Yeah, for the definition of style that we have inside the atom text module.
Right.
Which is not a style sheet of
this
any
style
sort.
should be an atom text.t.
No, not style. So
okay,
what I'm suggesting is that the make function
will actually create the atom text.t by using the style you're passing.
Exactly. So we don't need to make the consumer care about how we go from this style to anything more internal.
So this will be coupling the React component, right?
Yeah.
To the generation of the styles.
Totally.
The actual underlying styles that it's going to use.
Yes, totally.
Okay. I don't think it's bad or good. I just think we need to be aware of the trade-offs. Just wanted to make it clear. All right.
For sure.
So that means that if we have this this record that is the component itself, then the first thing we want to do is we want to take this style and turn it into the actual styles we want to pass down to the component.
Yes, which we do in 2 steps now, right? First, we get the actual atom specification, which is doing the atom make for this.
So atom text make.
Yes, and hopefully we can do that with style.
So this should be okay.
Yeah.
The type checking is not working nicely.
Yeah. So this could not yet be CSS, right?
No, of course. I was thinking that there actually is another function that you pass.
Oh,
it
right.
on,
So now we have to define that function that goes from the atom text particle set, essentially, into the CSS.
Okay, so I'm going to say that there will be a module called CSS. This could be called anything else. And then in there we'll have atom.text.
Yeah, it's kind of do or build. Yeah, exactly. Very straightforward, really.
Yeah, okay.
Yeah.
Of course, the path to the modules could be simplified or changed. That is not what makes or breaks the type system.
Yeah, definitely. I mean, the
system.
toCSS function could be inlined around here. Since this is very platform specific, maybe we don't need it to be in a separate module.
The reason I wanted to put it there is that right now it will clutter a little bit what's happening
for
here.
Sure.
Because I get the feeling that we're going to be done with this component fairly fast.
Yeah.
We're going to need to add more of these two CSS functions in other places.
Yeah.
And I would rather they weren't coupled to the actual component.
Got it. It's also good to be able to go to the place where the two CSS functions are and think about them in isolation.
Right.
I mean, we are very safe now with the types, but if you wanted to unit test this, I'd rather unit test this function and just snapshot test the actual component.
Right. Which I don't think we'll be able to do.
No, let's not even try.
I'm saying the snapshot testing.
I'm saying that I understand how it could be beneficial.
Cool. So what we know about this to CSS is that it will take a design system atom text T, right?
Yeah.
And it will turn it into, I think we might actually need to bring in a CSS library. Or first we can have a look at what ReasonReact comes for.
Exactly. That's I sort of assume ReasonReact will have something for the
like a style, something for it.
Correct.
I don't really know what it could be, right?
And probably the styles are somewhat mapped to the component type. I do know that TypeScript has them, so I will suspect that all the more reason for ReasonReact to have them.
So in the meantime, okay, there is something here, style for ReasonReact. Yeah, that's sort of exactly what we're looking for. It has a style module, React DOM RE. It's not necessarily part of the ReasonReact module, but it's part of React DOM.
Makes sense.
RE.
I mean, it's not for every platform, so.
Exactly. And it has a make function that I'm just going to make a guess. It takes a crap load of optional properties for CSS things.
I mean, it ends with the comma unit, right?
Yeah.
We've seen that in Reverie. We were recently trying out a library called Reverie, which is a library for UIs, kind of like React, but more cross-platform, let's say. Like it compiles to native code in many platforms. It's quite nice, but there seems to be a pattern of these variadic functions that get name parameters that to let the function know that you passed the last parameter of the lot, you send the unit.
Right.
Weird notation, like I don't know where it comes from, it's a bit odd, and I think that when we did the Reverie update it was gone, but anyway. I
think it's something that appeared a lot in the early Reason libraries.
Yeah.
I haven't seen that often with OCaml libraries. I've seen it sometimes where you want to take the parameters, but you don't want to force execution until they actually say, hey, give me this unit, right? Like actually call me.
Yeah.
And in other languages, you would just type like F, and this will be the equivalent to giving it the unit, which if I actually save this, you will notice that the reformatter will actually take it away.
Right, because calling with unit is like calling with undefined in JavaScript.
Right, which like semantically is very different, right?
Yeah.
But it's sort of the same thing.
Yeah.
All right, so we know that there's a style, and then if there's a make, there should be a style.t somewhere.
Maybe you don't have access to it, but it's fine because we can call the make with, you want to know the update. We want to know the output.
We need to know the type, right?
We don't have to.
No, that's true. That's true. I just wanted to make it obvious there.
Yeah, exactly. I'm all for doing the type annotations, even when they are optional.
Yes, precisely. I think they're really good docs.
Yeah.
So here we have a DS text or like a DS atom or DS style, we can call it. And now we will need to turn this into one of the other ones. So for now, I guess we could actually do just a quick React DOM re.style, so we can refer to this as style. Just making a small local module binding. If we open React DOM re, we get the same thing, but we also get a lot of crap that we don't want in this scope.
Yeah.
Whoa, what did it do? It did magic. And in here, we will just end up building some style, right?
Yeah.
Cool.
The unit is gone.
Yes.
I saw you putting the unit right. It's gone.
It went away.
Yeah.
All right. So we need to fix now our text component usage. We know that it will require a style, and of course the type of this should be sound now. Okay. So it clearly is sound because it's not complaining about it on the right, but my integration with bucket script toolchain or the tools around it is not very good. It works much better with the native tooling. We have a text and we want to pass it a style. And to pass it a style, we want to go into the design system, add some text, and we want to give it one specific text style from here.
Yes.
Which one do we want to start with?
Detail.
Detail.
Yeah.
Code, or is it just detail?
It's just detail, right?
I think so.
Is it?
We might need to do parentheses here or braces. Oh, sorry, it doesn't take the tilde. Cool. We can tell that it compiled. So just for kicks, to see that we are doing something with this function, we can set a color here.
Yep. I was going to suggest Comic Sans, but color is better.
Let's do font family, Comic Sans, and then we give the unit, and of course this is again an equals. We're not using this yet, so that it compiles now. Good, finish compiling. And the last thing we need to do is actually use the CSS.
Yeah, that could be useful.
So yeah, precisely. So I guess that will actually make it. Yeah, that compiled. So
Awesome.
If we refresh, we should see the same text. Actually, it's already reloaded. It says font family Comic Sans.
Maybe it needs some quotes or something. I mean, it's working, which is what matters.
I might not have Comic Sans.
Right, it's not
Thank
in
God,
Mac.
it's not in Mac.
Wow,
Look at that.
It's amazing.
Thank you, Apple.
Yeah.
Thank you for saving us all. All right, but so far we've defined a component that from the outside we use by saying, hey, I want you to be this detailed component, right?
Yeah.
And that's limited. This input, this style is limited to only things that we right now can turn into CSS, which
Right.
are only things that we can build with our design system.
Yep.
So it's impossible for you to make a text with this component, right?
Yes.
Just with this component,
Correct.
right? By cascading property of CSS, you could definitely make it look different.
Yeah. You can do whatever you want.
Exactly.
You can get the ref for the DOM and go nuts.
Yes, exactly. But if you use this text, then you will already be building something that fits into your design system, which is really nice.
Yeah.
Okay, so now let's actually flesh out the properties for this particular atom.
Yes. I'm taking a look in the design while you get at it, so I can get an idea. Input field, good. So, and we're not mapping directly from detail in itself. Rather, we are mapping from, oh, right. I think we made a small mistake in here. The two CSS does not go from the, it still needs to build the atom, right?
Yes.
So that's what it actually gets, exactly.
Yes,
That's
exactly.
what it actually gets, not the, yeah, sorry, we didn't do any mistake. It's just that those are the properties we need to use. We don't need to use the properties of the,
Precisely.
good.
So here we need to do size and what do you call it? Weight.
Family and color.
Well, actually, there's a small problem.
I'm
Right.
listening.
This type is completely opaque.
Right. So the CSS the two CSS should be in some way tied to this, so it's not.
Well, you would think that, but if we do that, right, then our design system now knows about an implementation, which is CSS.
Yeah, I know what you mean. I'm not suggesting putting the two CSS in here. What I'm suggesting is that maybe what you want to expose to the outside world is just that style type, right?
Yes, but when we want to implement this, when we want to interpret this style as CSS, we actually need all of the properties that are defined.
Yeah, definitely.
So something that's, it's a pattern that is very interesting. Droop in Discord, if you want to just bug him, @Droop, suggested it, and I started looking into it, and it's documented in the recent design patterns, is the, what's it called? View constructor plus view. That lets you keep your actual internal types abstract without losing this pattern matching that you need to recover data.
Okay.
So we could use something like this.
I see what you're going
to say you make a style from style to T, and you recover the style viewing the style from a T to a view. Now in this case, the view will be the same thing, but that means that if you internally have to refactor your style, right, your internal type T, you don't need to refactor all the code that is depending on its shape. Oops. So we can say view here, right?
Yeah.
And then we're just going to put this up there. Some of you might be thinking, oh, but that's just duplicating a lot of code. It will really cover your ass from any big refactor you want to do on your design system, which
I suspect also strongly that you could do like the attribute accessor of Ruby, like some PPX that generates the view.
Precisely. The problem is that the view will not necessarily always match.
No, but at the start it will probably match.
Exactly. Here essentially you will get a T and you will return a T, but the only difference here is that the type changed, right?
Yes.
Cool. I think we might have something missing. We have a type view, we have type T. On the right hand side it says, okay.
I am confused about something. Right. There you go.
So instead of casting it, I'm not sure if I can. I will have to deconstruct and reconstruct it, which this sort of makes from T to view.
Right, that was what confused me. It's not T to T, it's T to view. And it doesn't get confused about the fact that view is the same name, because one is on the language level and the other one is on the type level.
Yeah, precisely.
Different namespaces.
So right now we do need this annotation because both of the types are the same. So this is inferring that both of the types will be the same. But we need to tell it, no, actually use the view for the view function.
Yeah.
And that essentially means that in our CSS, right, we will get this variable, which will be the, I guess DS style is as good a name as any. And we will just need to pass it through a function that will live in here. That will be called view, right? So if you call view with the style, then you should be able to pattern match on this. And in here we will have a size, a weight. What else do we have? Family and color.
Right.
And here is where we will be able to say, okay, let's just build that up. Let's just build that actual style.
Cool. So each of these, size, weight, family, and color, the values of those come from the particles.
Precisely.
So they are not values that we can shove into the CSS right away. We still need to map them into actual CSS values.
Exactly.
I could imagine that we can create two CSS functions for each of those as well. So we can have exactly. We can have particle, and then we have the size particle, right? Or there you go. Yeah, so we can remember what those are.
Automate this and see if it works.
Yeah, because we're going to have to turn those into pattern matchings of.
Yeah, exactly. I think it will be obvious in just 1 second.
Yeah.
Let's remove the brackets. Oh, why are you doing that? There you go. And also remove the closing brackets. And now we can replace equals with equals and then font, right? And then if I replace the semicolon with arrow true semicolon, then save. And did that not work? What did not work? Line 14. Oh, sorry, that last change actually didn't happen. There you go. Save. Oh, so now we can easily essentially map each one of the values to a particular CSS value.
There you go. So we can ignore the spacer sizes right now. I think you can leave that to true. We're not going to use it yet. Font weight we're going to use.
Okay.
So regular is going to map to 400.
400.
Just 400. That's how it's defined in CSS.
Brilliant.
So I think we should use string. I did have TypeScript issues when using numbers, so I suspect it should be strings for this as well.
We can have a look at the type of make.
Yeah, that would be brilliant. Yeah.
Style make. Didn't manage to type it. Brilliant. You are great.
If you try to put font weight into the make of style and just check out the error.
I think that's a good idea. So font weight, this will be calling weight on particles to yeah, I think we can actually call this, because it's inside the CSS module, it should be fine to just call it font weight, right?
Right, that's also the name of the particle though, so it's fine.
Yeah.
Maybe it's slightly inconsistent that the atom doesn't call it that way, but I think it's fine because contextually it can only be the weight of the font in the atom.
So
Okay.
it actually is a string?
There you go, cool. Yeah, apparently because you can also pass bold and so on.
Right,
That-
yeah. This
that's-
enumeration includes things that are not numbers as well.
Exactly, and these numbers are not really numbers, it's a weird thing, like it's not actually like 600 in boldness, it's just a representation. It's kind of like HTTP error codes.
Right, yeah.
Like it's
precisely.
502 number. It's like
Exactly, yeah.
it's more like a code really.
So how would we go about adding font sizes? I think we need that, right?
Right. So I can actually check in the Figma spec for that. So what is the main? The first size is called main. The main one is the one we're going to use for the title and for the text of the search. Is 40 pixels in size. And these ones we actually can use, and I would recommend using numbers.
40.
I suspect we can do that if we.
We can try.
Yeah,
Let's see what the API uses.
Yeah. So the second level of text that we have is 24. Then
1 second. It requires strings.
unfortunate, but not super surprising. 40 px. And details should be 15 pixels detail. Body should be 24 and code should be 20. There you go.
For those out there with OCD, why is 24 outside of this 5 increment scale?
Yeah, no good reason. We were eyeballing the sizes when we were designing this.
Right.
We
or
might
is it
come
a
up
1
with a
pixel
scale.
increment scale?
No, it is not. It is not. The increment scale that is a standard to use follows. I do not recall. I think it might be the golden ratio. It might be, but the sizes are fairly fixed. You might be familiar with the 12, 15, 18, 20, 24, 48, 36, and so on. Those pertain to a scale that has been deemed harmonic since time immemorial, more or less, just translated into pixels. 40 is outside that, but other than that, we are following that scale more or less.
All right.
I don't think 20 is there. But yeah, the short answer is arbitrary right now. It should look good on the design when we tried it.
So we need to do font family now.
Yes, and for the mono font we were using Roboto Mono, and it's just, yeah,
Fallback.
yeah.
What
Let's
do we
add
use?
mono space. If you want, you can put Menlo or something that will work in the Mac. Otherwise, I can give you the string for getting Roboto Mono out of the Google Fonts, so we don't have that problem.
Cool. This will still happen at the HTML level.
Yes, this is 100% HTML. So, Roboto.
Do you want to send it on the live stream?
I can do that.
Thank you.
Select this font. Email selected. Customize. We also only use the regular size, and we're only interested in Latin since it's only code. Okay, got it. There, we posted it in the live stream.
Brilliant. So we take this and we throw it in the head. Cool. So continuing, we have this module, and for the sans.
For the sans, we wanted Helvetica.
And if Helvetica is not present, Arial.
Yes, correct.
Arial sans serif.
Sans serif, yeah.
Cool. That should be good enough. The last thing we need to be able to use all of the properties in this
the
particular
color.
exact
Correct.
is the color.
So our black is actual black, so that could be the 0000. I think we can pass strings, I suspect. Let's find out. Okay, in that case it's going to be the string like a pound or hashtag. There you go, and 6 zeros. Then the second color is error, that is red, and this red is EF, and the rest is zeros, so 4 zeros. Then we have a gray, which is here, it's a 616161, and white is actually white, so it's just FF. There you go.
Cool. So I expect this to already have been updated and to show essentially what are we expecting to see?
We're expecting to see a text that is Helvetica, 15 pixels in size, black and regular
weight.
Yep.
Let's take a look. We can close this. And we have text as Helvetica, 15 pixels, 400 the font weight, and color is, black.
That is fantastic.
Brilliant.
It, as you said, it's indistinguishable, if at all distinguishable, from the original.
Right. I guess that now, because we have implemented all of the properties we need for text, we could now throw a div in here, right? And throw a few other text styles, and essentially just get something out of them for them.
Definitely. Let's try the main error.
So this should be a detailed text, and then we can say this should be an error text, and this should be error, as we said, right?
Main.
Main?
Yes. This is the level of text is main. It happens to be one that you can parameterize.
Right. Main had black, white, and error.
Correct.
Brilliant. So error.
Let's figure it out.
That compiled.
That's perfect.
Refreshed. Awesome. Okay, this one is very big.
Yeah, that is because of the zooming, really. Or part.
Right, it's because it's 40 pixels, but this is the size that it should have, right?
Yeah,
that's
correct.
The 40 pixels.
Yeah, that is correct.
So I guess something we could add here would be a new line, just to make these things.
Yep.
I wonder if we can do a BR like that. Yeah, that works. It's just for us to be able to see these are different things.
Yep.
Okay.
There you go.
And now, what else?
You can do a code, but it's white, so you have to set a div with black background around it to be able to see it.
Quickly do that. We can do React DOM re.style make, and this will be background color, and this will be black.
Yeah, you can do it.
If we do that, then we can do style. What's the style?
Code.
Code.
Yeah.
Oh, sorry.
Yes, you need
Forgot
unit.
the
Yeah.
unit at the end. I think it's not code. It's example code.
Right.
Quite semantic. It's not just any code. It's a code from the example.
Correct.
Okay. And that's white as well.
Yeah.
Actually, morphism, this function that goes from our design system, which is completely abstract, right?
Right.
Into the underlying representation, which will be CSS.
Yeah.
And we've been able to create a component, right?
Yeah.
That can only display valid styles.
Yeah.
Of course, it still is just let's say a unit, and it's not a big page with lots of components that can be encoded, that have more rules, but it's a start. Like
Yes.
from here, we could definitely try to build a bigger element, a bigger component. I guess
Yes.
we're calling them molecules,
Yes.
right? We could try to build a molecule that encodes some of these things more strictly, so that if a colleague of yours or you yourself, right, on a bad day, are building one of the UIs, then the compiler has your back, and you want to build something that the design team will come back at you and say, "Hey, look at this.
Yes.
We need to redo it."
Yeah.
Okay, so, well, how do you want to proceed?
So I think this was very, very neat. I can point out that there is a small shortcoming in the definition of the text. We also need a line height that is not represented inside the inside the styles of the particles in the atom. It's just a CSS thing in a way, because it's completely correlated with the font size.
Right.
So we can add that. It's kind of an optional, but it would be nice to have it already just for completeness.
Mhm.
So it would also illustrate how there is a difference between the particles that specify these things at the entire system level with respect to the actual CSS styles.
So
Right.
we could say for the family comes back with the name of the family, and in the tuple, the size of the...
The size does that.
Oh, okay.
The-
So,
yeah.
right.
So for the 40 pixels one, the line height, that we don't have a specified line height actually. We should specify one. Let's go with the 50 pixels. What's happening is that we have it inside the input field, so
Right.
it cannot be multi-line. So that's why we didn't care when defining it. So
Precisely.
let's see the detail one. Detail one has 20 pixels in line height. Then the body one, which is a 24, has 30 pixels in line height. And the code one has also 30 pixels.
Cool. So now, of course, when we decompose the size, we turn it into CSS, we run into the issue that it's returning a tuple of strings rather than a single string.
Right.
And of course, this could be typed much more nicely, but for the time being, we're going with the strings that the style library uses, right? Your component doesn't actually know that you're just using strings underneath. You could
Exactly.
definitely have, for example, polymorphic variants here. So you could say this will be pixels, right? 40,
Yeah.
and it will be an actual integer.
Right.
You have to pattern match to extract it and whatnot. And then
Right.
you have that information in the type system, right?
Yes.
So
Yes. I think it's important to highlight that there is a lot of room for optimization at this level of the implementation, right? But it's not the concern of the design system part.
Exactly.
This is more like how do you go from the abstract design system specification into an actual implementation.
Yes.
That is what this step is, and you can really go into a lot of interesting tangents in that. But we're not concerning ourselves with those now.
So we can see here that either we undershoot a little the line height, or the I think the baseline is a little off.
That is perfectly fine, because we don't really okay, so we can care about how the box of the span is going to wrap the text. By default, the text is positioned in the middle of the line height, which is not the alignment that we want to actually have. But I'm not sure we still want to fix that. We probably want to fix that once we reach to the point that we are positioning this inside the molecule.
Right.
So what you're going to actually want to have is the text baseline sitting at the bottom of the footprint, and the size of the text component matching a multiple of the grid size. This is so that you can place this atom text in a way that composes well with the rest of the UI. Like
right.
If you go to the Figma specification, there is a good example of what I mean exactly. So if you look at the TLDR text below the Tarro input thing, there you go. So what you see there is not just the TLDR title text specification, you also see this blue semi-transparent box, which represents the area that the footprint of this text is going to occupy. So it's good that now you have highlighted the box that Figma says that the text occupies, right? So that's the box. If you don't do anything about it, that is the box that the text component is going to have. That is what the DOM element is going to occupy on the screen of the browser. So when it's composing vertically, that is the box that it's using.
We can see that this one, for example, if I highlight it.
Right, well, now the box is even bigger and they overlap a bit. This really highlights how many problems are there with the way the browser manages text rendering and baseline alignment. There are really small issues. So in the end, what you want to have is that the box around the text makes sense with the rest of your components, and the alignment of the text inside that box should be to the bottom of the box.
Right.
And the alignment should be the thing that should be aligned to the bottom of the box is the baseline of the text, not the furthermost descendant. So not the tip of the P or the Q or the G. You don't want those aligned to the bottom of the box. What you want aligned to the bottom of the box is where the letters start from the bottom, the most letters, what is called the baseline of the font.
So if we were to zoom in here, we'll see that we actually don't have any descendants in this ones, but we can quickly add a G, for example.
Exactly.
And the PQ, for example.
There you go. So what you want to have is that the box, which is the black part in this case, right? Because that's the one that is occupying space. What you see in this highlight of the browser, that blue semi-transparent or gray semi-transparent box that you see, is the size of the font, the footprint of the glyphs, let's say. So you have the G in the font definition, in the original like true type font or open type font definition. The G for this size occupies that box.
Right.
That's what you see highlighted when you select it that way. What you see in the black box reflected is the line height that you manually specify.
What would be a way of taking this text and making it fit make the baseline of the text fit or be aligned with the bottom edge of the container?
We need to manually do that by adding a negative margin on the bottom of the box.
So the box itself, right?
Right.
Needs a negative margin.
Correct.
Margin bottom -1 pixel.
Mind that you're in a span, you might need to set it to display block before being able to do that.
Okay. Let's just give this a quick shot and see what the result will be. Actually, just doing display block seems to have done it.
Oh, that is peculiar. I did not expect that.
It's
But
a little bit below though. It's not.
Yeah.
It's not exactly.
Right. So that those are the subtleties of what baseline constitutes. It's more of an average thing. The E, for example, and the S, because those are curved letters, they usually go slightly below the baseline by design. So what you want really to align, if you want to find something, is the bottom of an N,
Yeah.
or the L or the I.
For example, I increase the line height, and I see that it increases on like.
Right. So we shouldn't touch the line height. The reason for that is that when you have enough text that is going to fold, you want it to pile up according to your line height.
Right, precisely.
So you are not allowed to touch it in order to make it fit the box.
So what else do you touch?
Margins and paddings.
So do you touch the margin bottom on the text?
Correct.
That doesn't seem to.
It doesn't do anything.
I guess that's the.
So it's interesting though that you all immediately got it aligned to baseline. So in this case, it doesn't seem that we need to do anything, but that is confusing.
It's almost aligned though, right? If I go line height to up to 23, then I can definitely see that right there is exactly where it's fitting, right? If I zoom even more, that's the most I can zoom, but 24, right?
Right.
1 pixel less, that fits the H and the L. But anyways, it's interesting to see that there's so many quirks around aligning text.
Right. So what you can do also is set padding top, padding bottom, until it fits.
Exactly.
That is what you manually want to do.
Right.
But once you do that, you're going to have to do some negative margins sometimes to get the box as a whole to be a multiple of the grid.
Right.
But yeah. But this is the thing. Maybe it's not necessary to do it right now, since we are not composing it together and we lack context to show what the problem is.
Precisely.
Good.
I reckon, I don't know how long we've been at it. It's 8. Let's
Yes.
just double check the time.
Yeah.
And it's just an hour and 15 minutes. I reckon we can try to do just a proposal. We could try to do the input field.
Yeah.
Not necessarily all the states, but maybe, I mean, to be honest, the text states we have already because we have the text atom, right?
Yes.
So if we get the exact, it might require some tweaks.
Yes.
But if we get this component, then we might run into situations where we need to tweak the results of the text atom for this particular atom, which is the box, right?
Yes.
Which I think will be interesting to see how those different atoms kind of interact with each other. One of the properties they have. Do they repel each other? Do they bond immediately, or what's happening? And if we do that, and it happens that we do it in the next 40 minutes or so, maybe we'll have all the elements we need to put the navbar.
Right.
Which will require a little spacing.
Right. Cool. That sounds
like a plan?
Yep.
All right.
Sounds reasonable.
Sounds reasonable. Good. Yeah, this is reasonable coding after all, so it should sound reasonable. So if we go back into our little design notes here, very quickly, we have set up buckle script. Yay. Let's go for it. Done there. Done. And we have created a text component, which is great. So now we're gonna try to render the input atom, or I think this is a molecule, right?
Yes.
So search input molecule. And if that works, we'll try to search to render the navbar. What will the navbar be there? This
an organism.
Navigation. Okay, organisms. Interesting. Organism. If we do this, then we've managed to encode some design rules, render an atom, render molecules with those atoms, and then render an organism. Which means I should be able to take the rest of the design system and implement it on my own. Hopefully it will work just fine. And if you're looking, then you have a really good idea of how to bring this type safety into the design system as well at your next or current project. Alright, so let's go into the search input molecule. Let's begin by just making a random component. So we're gonna call it search input. I'm gonna change the name here. What should this do?
It should call a couple of atoms, right?
Okay.
So we're going to have to define those. Maybe first, maybe.
So what are the atoms that we need to call for the input?
For the input, we are going to need to have a border atom. We're going to need to have a background atom.
Okay.
Like search border. Well, right. We can just say background and border. The background has a color, that is correct. Border will have a color as well, that is also correct. And just the border. In our particular case, we do not have radii or widths or something like that. And the approach to the system is that you do not add any property at the abstract level that you're not actually using.
Cool. So this is very pragmatic.
Exactly. That is a rule. Otherwise, you have infinite properties, right?
So this reflects your actual system and not just
exactly
not an ideal one or like all the possible potential states.
Correct. There is no template of the type of properties that the atoms in a system will have. The properties that each atom type will have depends on your actual system.
Right. Cool. So we have a background and a border. I think that if we open the small design notes, we'll find out whether we need this some more. We have a text style, so that's covered, background and border. Sounds good to me.
Yeah. So the text style is a bit deceiving in our case because we're going to need this text to be an interactive input type, not simply text. So maybe we deceived ourselves a bit. We might need to duplicate this text atom into an input atom that receives a similar set of properties.
Right.
Maybe less actually, because the input that we only have one input that has only one size, that has only one font, and that the only variation that it has are a restricted set of colors.
Right.
So we don't need the full text specification for our input atom. So I think we can do that. We can create a new module at this atom level that is input.
Would
atom.
They at the design system level be different things?
Well,
because we can always, and I see your point, we can always have a different...
that is interesting. That is interesting. So you're saying to the text component, we are passing a property saying this is a...
No, what I'm saying is if the text component is... Sorry, if at the design system level, right?
Right.
The text that we're using is the same atom, then perhaps the way that we either turn it into CSS is different for the different molecules, such as the search molecule, right? Will use some atoms that are specific to it.
Yeah, that is one approach for sure. That is the approach that we are following. I think in this case, we could take the style of the text atom and receive it in a separate React atom, which is called input. So we create a new React component called input, like we have the text component. And this input component also receives the atom text style as a property.
Right. Okay. So this will receive a text style, and it will receive
a value. So it will not receive children since it does not have a...
The signature forces you to receive children, but you can ignore them if you don't need to.
Right. This couldn't be at the search input level, right? This could be at the atom input. It's not that's exact. So this is the molecule.
When you're saying atom, are you saying... So we have three levels, right? We have the React level, we have the CSS level, and the design system level.
So in the React level, we will need an input component.
Right.
That is not the search input. The search input is the molecule. We need an atomic input for the actual interactive input element.
Okay, let's call that input.
Yes.
Are you?
Yeah.
And if you give me 1 second, just for clarity's sake, I'm going to make a few folders here. So I'm going to say, actually I'm just going to rename some of these things. So search input is going to be molecule search input, or Or should we just make a folder for atoms? Maybe that makes more sense. Text RE becomes atom text RE.
Are you thinking at the component level or at the design system level?
Component level.
Component level. I could have folders for atoms, yes.
Okay. So folders in themselves don't actually namespace things, right?
So you need to still put the atom text in the file.
So it depends. Dune, for example, will do that namespacing for you automatically based on the folders and the other configuration described in the build files.
Right.
But BuckleScript doesn't believe in that. It believes in not doing that. Okay, so never mind. I think for now we have few enough components.
Cool.
To be able to just go away with another.
Hopefully
input.
we will have very few.
Yes. Okay, so we have an input here. I just thought that perhaps there is a very nice abstraction close by that we can just use to split these things in a more clear way.
Yeah.
All right, so we have an input field, right?
Yes.
And this input will take a style.
Yes. Which is of the type of atom text. Atom text style. Sorry.
Okay.
From the design system.
Yes.
It will get a value.
What do you mean by value?
So it's an input field, so it does not have children. It has a value that is shown.
Right, okay. So it gets a value, and I guess it gets an unchanged.
Correct. It also gets an unchanged handler.
Cool. But what other styles do we need for?
We don't need any other styles. What we're going to do is to kill any default browser styles from this input field. And every style regarding background and border is going to be applied via the separate atoms that we have for it. So the search input has an atom border that will set the border for it, and an atom background that will set the background for it.
So if I follow what you're saying is, this is the search input, right?
Correct.
This one will actually have some sort of container.
Correct.
That will set up the borders and whatnot, and internally, instead of just showing something, it will show an input.
Yes, the div that div around, that will not set up any styles. It will set up some flex basic styles, but it will not set up any background or border styles. Those are separate atoms.
Okay, so we would need to create a component for background?
Yes.
Alright, so then essentially this could be background.
No, the background does not surround the input. It's a separate component. It's just behind in the rendering tree. The reason for this is because you don't want the input to re-render when the background changes color. It has nothing to do with each other.
So the search input, right?
Yes.
Will end up having a series of components.
Yes.
Like this.
Yes.
Okay.
Yes. Yeah, see how this way we respect the abstractions of the system all the way down to here. Yeah. This allows us to do a lot more enforcements that we would be able otherwise. This makes the background and the border very, very reusable. So in order for the background and the border to be as reusable as they can, we're going to have to set them to position absolute and to cover the entire size of the component.
Right.
But that is just the internal thing that we're going to set by default in them. And then wherever we place them, as long as we place them first in the DOM list, they're going to be rendered behind the other things.
Right, I reckon that either you have the rendering order right, or you have the Z index right.
You can do Z index, or you can do some other ways of enforcing and ensuring that the proper stacking of the rendering things.
Right. Okay, I'm not gonna save this file. I'm gonna leave it there. Cool. Let's finish up the input field.
Yes, for sure.
So here we actually want to have an input field.
Correct.
I reckon. And this will take no children whatsoever. So we can just close it there.
Yes.
And for style, we will have to compute some style.
Yes.
Now comes the question, right? This will be the text style.
Yeah.
Oh, I guess.
With some luck, there is nothing to do.
Unless, I guess this is it.
Yeah, I think it is. Just compiles to a different primitive. Yep. Different platform primitive. But
so
that's not.
If this is the case, then I'm going to do something.
we will need to propagate the value on the on change.
Yeah, we can definitely do that. I just wanted to do a refactor. So the style, since it's not reused, we can just compute it in line.
Yeah, definitely.
And then on change. And then I think I can just do that value. Yep, looks like it. So we could try to use this input and see what it looks like. Keep the VRs there. I'm gonna start adding things on top. And this should be input, and it takes a style, which again can be detail. There's a few styles there that we did not actually.
It does not have a children, just a value.
Oh yes, precisely. But it also needs a value, which would be like hello, or actually tar. That makes more sense.
Yes.
And then by change, we can just pass in a.
Yes, the lambda to unit. Yeah.
Yep. So this is complaining because this is called text style.
Right.
And now it rendered, and if we go back to this already should have rendered, and we have there something that
is the detail one, right? Let's set it to the other
thing should be main.
Yes, main, and let's put it to black.
Now, all right, we just built a component that is now valid.
How is so?
So, detail is not a valid input.
Right. So, yes. So this is why we could have introduced an atom called input at the design system level.
Right.
Then we cannot do that anymore. You don't have to say main or the other ones. You will just have to pass a color. That would be the only available option.
Right, and then the colors will be limited there.
Yes. It's a trade-off, right? Because input might be generic enough that you want it to support the same stylings as text. As you said, when you're thinking completely in the design side, an input and a text are both way of representing text. So it feels that both should be able to represent all the text variations that you have.
Right.
That might not be true.
Exactly.
Good.
Interesting.
Yeah.
I think there are ways in which we could limit the values that we have.
Yes.
Again, the same sort of trick that we did with polymorphic variants for all of the texts. Remember that we said the main color can be only black, white, or error.
Yes.
Right? If these were polymorphic variants, right? When we define the type of the input, right?
Right.
We could say, hey, you should only pass in a main.
Right.
Which could work.
Yeah. Correct.
So, yeah, I mean, we don't need to do it.
No,
but it's doable.
yeah. It's one of those things. If you think about this, like growing a tiny bit more, it's very likely that you will have input fields with other text styles.
Yes.
So it does feel like an unnecessary extra restriction.
Right.
Like,
perhaps as the as the design system matures,
yes,
you can narrow down what cases should never happen,
exactly,
and then enforce them with the type system.
Exactly. And the evolution will be together, right?
Exactly. So right now we have this here that essentially has all the properties we set up for it to have.
Yeah.
It also has some properties from an input that we probably want to kill.
That is the thing we should do, exactly. So we're not going to encode background or border colors here, so we need to kill those other properties.
So we can do combine, and combine takes, if I remember correctly, 2 of the styles. So we can do style.make, and then here we need to set those styles to nothing.
Yes, so background color should be transparent. We need to let anything through.
Right, okay.
We should set the border to none. I do not recall that's exactly how you do it. I tend to do border with 0 because of React Native compatibility. That should work though. So if you want to go for border with 0, that would do. Instead of border none, border width. Yes, correct. And then we also want to kill all paddings, since we want to manage the size of this independently from.
I reckon the margins as well.
It does not have, but
okay, it doesn't have it, then it doesn't need it.
It's kind of dangerous, right? Because some browser could decide one day to add some.
Yeah, exactly.
Yeah.
And then your whole design system looks bad.
Yeah.
So we have some other things here like border style that I guess don't matter because the width is unset. The WebKit appearance, letter spacing, text indent. I mean, I reckon we can go very deep overriding these properties.
Right, it's not going to be necessary for our case right now. So the next thing we should probably do is to set the border.
To create the border.
Yes.
Okay, perfect. Cool. So this makes the text field. I reckon that we should be able to type in it.
Maybe.
We can't.
It's fully controlled. You pass the unchanged handler. Oh, there's another thing we need to remove, the focus outline.
Right.
We set the outline to none.
What's it called? Is it
just outline?
Focus outline.
Ah, it's just outline. It's not focus. There you go.
So I'm gonna suggest that we have a default value, but we'll leave this handled by the DOM for now, so we can type and see things changing.
Sure.
So we can keep it there, but we do default value equals value. That way. I did not know if that was name.
Yeah, it's the same as React. Cool.
So this gives us an idea of what it would be like to interact with this.
Yes. Now I remember that I think we changed the letter spacing of this. No, we didn't. Forget about it.
My computer screen is so dirty. I was gonna take a picture of it, but no, I'm definitely not gonna. Okay. Cool. So now we go for the background, you said.
Or border. Yeah.
Sorry, the border.
Yeah.
My short-term memory is terrible.
No, it's okay.
And I reckon the border is gonna be similar to this. So I'm just gonna border. And in here we will have what kind of row element?
I usually go for a div.
Sure.
If we were in an advanced enough situation, we could go for SVG and do a path for a border. The reason we cannot do that is because we do not know the size of the element that we're wrapping.
Right.
We need to rely on the position absolute. And we cannot use that to define a path, since paths are not defined in percentual terms. You say that the path goes from A to B, where A and B are pixel positions.
Right, exactly.
So if we were to know the exact sizes, we can do SVG path for the borders, and then we would have a plethora of options on how to draw borders.
Right, essentially whatever you could draw could be your border now.
Yes. And the reason I mentioned this at this point is because using a div feels a bit odd. It's very unmotivated. You're doing a border and then you put a div. Well, the reason is that we do not have a better primitive without using an actual drawing primitive.
Right.
But those drawing primitives like SVG require precise pixel positions that we do not have.
So for the actual styles, we will take the style input, right?
Yes.
For the border.
Yes.
And we will go into the border and we'll try to make one of them.
Correct.
And then we'll go into the CSS module, which has more or less the same, structure as well.
Yes.
And then we will try to turn it into CSS.
Yep.
And then what properties do we want to kill? We want to override.
Right. So we're going to want to make sure that it has position absolute, that it has left 0, top 0, right 0, and bottom 0, which if you're not familiar with this, it's a hack to make it cover the entire available area. It can also be done with width 100% and height 100%. It does not really matter.
What about padding and background color?
We don't want any of that. But it doesn't have any by default, right? It's a div, so we don't need to specify any resets. The border width you don't need either for the same reason.
Interesting. So I guess that essentially if you wanted to re-implement if you wanted to take this component, right, which is now built for React on the web.
Yes.
And wanted to do the same thing or reuse the same interface, to reuse all of the higher level abstractions in your UI that use it,
Yes.
But rendering down to, let's say, a native application that runs an OpenGL canvas,
Right. Right.
then you would have different resets and a different way of creating the style, but you would still take the main style input and turn it into a border through the design system.
Yes.
So then this will be something like OpenGL, and this will be something like to draw like commands, and
Right.
then you evaluate those and whatnot.
Obviously, most OpenGL libraries are very imperative, so it would look nothing like this in the actual code.
Yeah,
But
absolutely.
hopefully you happen to be blessed by a declarative OpenGL library, and then you totally do that.
All right, so let's make this border.make and this border.css. So for the border.make, we actually didn't specify the different style of borders that we have. I reckon that we just have one.
Yes.
And in that spirit, let make.
Correct.
If we just have a single style, then we can just take a unit and return a particular border. In this case,
right. Mind you that we have a single style, but it have many different colors. So we still need to specify what color we're passing in.
Okay, so does it make sense for us to pass the feedback state into the border?
Right. Yes, that is exactly what we should pass.
Cool. So we say state, and then here we do switch state. And if we have a particle dot, actually, because we can just backtick them. If we have default, then we will return color with black.
Right.
If it's an error, then we'll return color with red, I think.
I think it's error.
Error, yes.
Yeah. Red mapping with in the style.
Cool.
Neat.
So in this case, we're just leaving the T. We're not doing the T and view, the constructor and view pattern. We're just leaving the T there. It's definitely something to refactor. I'm just gonna leave it to do here.
Right. So you mean because this one is public?
Exactly. In this case, it's public.
Got it.
And the last thing we want to do here is go into the CSS module and say, let's go into the atoms, right? We will have a module for the border, and this module will have one function that will essentially be the same signature as there, right? When we take a style and we'll return a style, but it will be a little different. So this one we can deconstruct into a color.
Yes.
And then we want to do style.make, and we want to say color equals to color. Might not actually be color.
Exactly. It's not color, it's border color.
Brilliant.
Yeah. And we also want to add a couple of default properties for border. We could add them somewhere else. Actually, we could add them in the component definition.
Right, so this is the bare minimum we need for the border to comply.
Right.
Everything else is just resets that depend on the platform.
Yes.
Okay.
The particle color there, what is that doing? The function on the that you're piping into.
Oh, this one? It turns black.
Oh, sorry. Yes. Of course.
When we did the other one.
Yeah. We got it for free.
It's really nice to see that some of the things just are done.
Yeah. I didn't expect that. I guess it's because in some systems the same color error could map to different actual colors on the case of a border and on the case of a text,
right,
and so on. In our case, we're not doing that. But
so now here, if we wrap this thing in a div, just to be able to throw the input with the border,
right,
and the style should be actually, because the style is just a polymorphic variant.
Yes.
Here we can say default like that.
Yeah.
And it should actually have a box, I presume. I don't know. Like, we'll see how it goes. Did it yeah.
Boom.
It did not work.
Okay, that is It's possible that this is because we need to set position relative in that div. I
In
don't
which
think
div?
we need to, yeah,
In this one?
right. Because the absolute will try to, grow up to what it can, right?
Oh, so this div, right?
Right.
Essentially is trying to cover everything.
Okay. There you go. That makes sense.
So if I do relative, then it's 0. So I reckon it should be absolute, but it's essentially asking.
Yeah, the wrapper should have position relative.
Yes, and now that works. We still can't see this one. though.
Okay. And that is because we need to add the defaults for the border width and the border style, which are inside the border component. It's not part of the.
Oh, right.
Yeah. There's nothing.
So if we were to
Nothing
change them
mysterious.
here, like border width, we haven't set anywhere.
Exactly.
So we do 1 pixel.
Yes.
Border style.
Solid.
There you go. That worked. Solid.
Okay, so is it cutting somewhere? No. Yeah, with the uncertainty overflows. Because I think it's actually going outside, maybe. Yeah. Anyway.
I think there's one problem is that it's over.
Right. Okay, so you can do the trick everywhere, right? You can say to the input that is also position absolute and left up and all those. So the position absolute stacking will start with the border and then with the input.
Right.
But there is another solution as well. You can say the pointer events of the border to none. There are many ways of getting around this. If you want to hard code it in the safest possible way and the hackish way, z index -1
For this one.
for the border. Yeah.
Huh. Interesting.
But I tell you, there are like 10 ways of achieving that.
Right. So it seems that we need to add these 3 properties for this to work in tandem with each other.
Right.
We could also redirect the input events, I guess.
Right.
But this would be the lowest
Right.
friction one right now.
Yeah, we shouldn't rewrite the input events. Remember that this should be accessible. So you cannot have guarantees that the border will be the target of any particular event.
Right.
You should capture everything on the input level.
Cool. I'm just gonna sort these bad boys, and of course the unit goes at the end. So now if this refreshes and this.
Right, we forgot the position relative. So
Oh,
if we place this inside the molecule, we can already set the position relative as part of the molecule.
Perfect. Okay.
The way we are actually doing it is that in the molecule, instead of using a div, we have a primitive that we call a block that already sets position relative and all the things that we need.
Okay. Yeah, we can do that. So
Yeah.
we will do search input, and this shouldn't take any parameters really. And then here we want to have a block, and the block, I don't know how many details it's going to have inside. What am I doing? Block.
Just children.
Right. Okay. So we can just save this as block, and this is really not going to take any styles, just children, right?
Yes.
And I guess it's going to be a div that will have some default styles.
Correct.
And we'll just put the children in there.
Correct.
And I guess I need to do react array. Do that, then it converts an array of elements into one element.
Yes.
So we need one style here, right?
Position relative. And in other cases, you're going to want to have flexbox as well, since you want a reasonable default rendering mechanism, layouting mechanism. In this case, it doesn't yet matter because everything here will be covering the entire input. The border will cover the entire input, the input will cover the entire search input, and the background will also cover the entire input.
Oh, look at that. That actually worked. Nice.
That is neat. That is really neat.
It's very interesting to be able to encode these things to the point that if something compiles, it's very likely to look right.
Yes, yes.
You know what I mean?
Yes,
Not just
yes,
work
yes,
right, like
yes.
not crash, but also looks okay, looks
Yes.
into the system.
I'm with you. I think it's fascinating. Once the design is systematic, then why not typing it?
I think it makes perfect sense.
Yeah.
All right, so what else do we need for our...
So there are two things we can incorporate now. One could be a background. Now, the background is a bit pointless in our particular design system. We do not have a background in the search field that is not white.
That's true, but we still have other things that we need to parameterize, right, based on the style of the search input. So if you are on the main style, right,
Yes.
then it's good, but if you're on the prompt, then you have the gray text, and if you're an error, everything is red.
Right, correct. So we need to differentiate when we have a value than when we don't have a value.
Right.
In the case that we don't have a value, we want to render a placeholder, which is literally a text atom. But we only want to render it when we don't have a value.
Okay.
So you might be wondering why not to use the placeholder functionality of the HTML input. And the reason for that is that that is not stylable to the extent that we want it to be stylable.
Right. So essentially, if we take an optional value parameter,
Yes.
if it's defined to be none, we will use one component, which will be the text.
Right. So we need to render the input always, because we need a target for the focus so you can type.
Okay, right.
It's just that we're going to not render the other element if the value is not there. So we only render the placeholder, which we render below the input. We only render it if the value is empty. So what you were doing is almost right. It's just
Okay,
we need to
right,
check
precisely.
if the value is empty.
All right, so I can tell you right now we have values and optional. If there is no value, it means there's none. Otherwise, we have some value. If we have no value, we can put a text here, right? That will have a style, and this style is going to be atom, text, and what was the style that we put for this thing?
We want the main and the gray color. That is how it's specified in the Figma spec.
Black, white, error. Huh. Why we have white as text? I think this white should be gray.
Yeah, that was supposed to be gray.
Yeah.
I guess we were tired last time.
Yeah. Alright. And in here we wanna, because this is a polymorphic variant, we can just say style. Okay, so we need the style part. Good. Main and then gray. Right? So this will be a text.
Yes.
And as a placeholder, we would have some value.
Yes.
That I reckon we could parameterize.
Definitely. We should receive the placeholder as a property.
And you always need to receive the placeholder.
Yes.
And this would be ReasonReact dot string text.
I think there is a small syntax error with the slash, trailing slash.
True.
Cool.
Not bad.
Neat.
And if we have some, right?
Then we don't do anything.
Then we do nothing.
Yes.
I'm confused. How do we do nothing here?
That's interesting. I don't know.
Is there a fragment? Oh, wait. Before that happens, that's the way you do it. And I guess this is an empty thing.
Probably, if it's like JavaScript, it should be unit, because in JavaScript you should return null or false.
Right, but in JavaScript you have this massive union type for everything, so you can return whatever, right? And you're expected to return a ReasonReact element.
I see what you mean.
So we can't really return any type. We will need to return something.
ReasonReact empty child. I am googling for that component warning documentation, children. This is JavaScript. Why are you showing me JavaScript? Separator, AB, make, AB, div. Well, to be fair, we can return an empty div.
I already did that.
Okay.
I thought it would be a reasonable thing to do while you were searching for the right thing.
Right.
And okay, so now that means this input, right?
Yes.
Will have the essentially, if it doesn't have value, it shows the placeholder. If it has a value, it will show the value.
Cool.
So now this thing here should be, if it has a value, it should be the value. If it doesn't have value, it should be empty string.
Yes.
Cool. So we can just say switch value, and if it's none, then we return the empty string, and if it's some s, then we return s. Now, I personally would have liked to write this with operators, but ta-da. But we don't have those at hand. Cool. So that works there. There's one thing that we are not using right now is the style. So we are assuming that the style would be default for the border, for example, instead of expecting what the style should be for the search input.
Right. The reason we have style there was because we copy pasted this from the text. We actually don't want a style in the molecule. We want a state, but it's not the same thing.
Right, exactly.
So we want a feedback state.
Feedback state.
Which we are going to use for that. Yes, correct.
And here, I guess we can say if it's...
we're actually forwarding it directly. That default was a feedback state.
Oh, right, yes. It would have been obvious the moment I typed everything, I guess. Thank you for that.
No worries.
But we need the feedback state to pick up the right one here.
Yes, that is correct.
Now, this is something that is interesting to me. How do we verify, right, that the feedback state that we're picking for the input text style matches what the design system expects?
Right. So if that's what you want, which is very reasonable, what we would need to have is a molecule type, which we don't have right now in the design system.
Right.
And go from the properties that you get out there, which might have to include the value, for example. In this case, it doesn't, fortunately. But the properties that we have that determine the search field state, search input state, sorry, which are the feedback state in our case. We need to go from that property into a full-fledged declaration of the properties that we're going to pass to every sub-atom.
Right.
Which is going to be either a heterogeneous list of atom definitions or something like that. And I am not 100% sure how that is to be modeled, because in my experience I never did that since I don't have that capacity. I'm working in TypeScript. But we could have a molecule type that we can construct that specifies all of those. And then the restrictions are encoded in there.
So what I was thinking is, this particular text, right?
Yes.
Can be built by passing in one of these styles.
Yes.
But there isn't really a need to pass all of the styles per se.
Yes.
So for example, if the input to creating a text T in the design system was a feedback state, then you would have much less options, because we have two feedback states, right? Either we have the black one or the error one.
Yes.
For the default or the error state, right?
Yeah.
Now, that doesn't mean that you're going to use it here, but it sort of tells me that maybe the input, just like the border, should be receiving a feedback state.
Right. This fits back to what we talked about of whether the input component should receive the same type of the text component or should be more restricted. The argument was that at the atom level, it's probably too restrictive to go with just a subset.
Right, like
at the
feedback
atom,
state.
exactly, at the atom level, we probably want to have the full spectrum of text options.
Right.
Since we're treating the input as a like implementation detail, the fact that the input is actually restricted to certain text styles. Yeah, yes. So we can abstract this mapping that you're doing right now from the feedback state into actual colors. We could abstract it into a type that we construct for the molecule.
Right.
But yeah, it is fairly complex, and I think I wouldn't say it's a bit out of scope. It just could delay us too far from what our pragmatic.
I think is there's a trade-off to be made here, right? Either you make your inputs only support a very small subset of valid stylings based on feedback states, for example,
right?
Or you leave them general, so you can parameterize with any text style.
I'm not referring to the atom input. I'm saying that the search input molecule.
Yeah.
The mapping that you're doing right now, see that you're doing a bunch of switch cases inside this definition. Some of those switch cases could be done at the design system level.
Yes, absolutely, exactly.
From a molecule type that receives the feedback step to be constructed, and it returns you, so it could be a molecule dot search input that has a make function that you call using the feedback state.
Right.
And that will return you some sort of heterogeneous list of atoms, which could include the atom border style, the atom background style, the text style, and the input style.
Right. That's interesting because you can have a complete representation of not just the styles, but also the layouting of the elements of the whole of the page in a value.
Exactly.
Then you can just traverse and turn into components.
Exactly. But that is where it starts feeling that it gets out of the scope, because you're getting into rendering details within your design system specification.
Right.
So it's interesting because a color code is something that we have aligned throughout the entire stack.
Yeah.
We use color codes in the close to as far close to machine as you can possibly go, which is when you pass the actual hexadecimal values into the pixels, not the pixel, but the layer that you can access, up to the design software. The design software that we use uses the same color coding.
Right.
We do not have that level of alignment regarding layout strategies. The design software uses a layout concept called constraints layouts, which allow you to anchor elements to certain parts of their containers. We don't have that same concept in web. We have an approximation in position absolute, but it's not close enough to really reflect what they do in Sketch or in Figma. The problem of this then is that the specification that you can extract out of the design software is not complete when you go to the actual implementation. And then it falls in the cracks. Some extra specification that is necessary for the implementation to happen, but it's really hard to call it part of the design system. It is part of the design system in the soft sense. That is to say, if you were writing a style guide on how to use it, a guide on how to use it, you will say the buttons go anchored to the bottom of the page, for example.
Right.
But you don't have that encoded in your types because you can't, not because you don't want to.
Well, you could.
You could, but then you need to build your own layouting concept, which is one step too far from where we are right now.
Yes, I think that we are not in a position to do it right now. It will be interesting to explore that, perhaps in a different live stream. I think there's definitely plenty of room in the design system space to look at how can we encode these constraints at the type system level.
Yes.
So that essentially making sure that you're building the pages you need to build is safe.
Yes.
But without, I mean, we digress, right? We're going a little bit by the branches.
I think it's important to clarify it at this point, because there is certainly an asymmetry between what we did for the atom to what we are going to do for the molecule.
Yes, precisely.
In the atom, we went to a level of specification extremely detailed, which is beautiful. And it really feels that the moment we're composing this molecule out of atoms, we are losing some of that. We are embedding logic about the design system in the render function. And that does smell, and it smells for a reason.
Right.
We want to do that at the type level, But we know that today the abstraction we're going to build at the type level is going to be unsatisfactory as well, because it will not be able to encode the layouting constraints. So it's going to be just a list or a record of some sub-elements with no particular layouting relationship between them.
Right.
And we're going to have to deduce what elements belong in what part of the layouting hierarchy in the render function anyway. Right? So to try to explain what that could mean is we will have a make function that creates a molecule of the type search input that will be essentially a record that will say border, and then you will have an atom style for the border.
Yeah.
And then you will say background and atom style for the background. It is nice, but then when you come here, you still need to put it somewhere in the hierarchy.
And there's no clear, there's more than one place where you can put it.
Yes.
And that's the problem.
Exactly. And when you say a molecule, this is still a simple molecule, but you can have more than one border in a molecule. That's perfectly fine.
Absolutely.
You can have more than one background, more than one text. It happens to be by coincidence that this one has one border, one background, one input, and one text.
Right.
But that is not a condition of what makes a molecule.
Yes.
So those record types that we're going to have for the molecules are going to be very ad hoc. We're going to start putting names that represent the hierarchy in the name.
Mm-hmm.
Right? You're going to say, this is the background of the label. So label background. Right?
Yes.
As the key in the record. That is really not what we want to do.
Right. In reality, what we would like to be able to do is encode something that looks like, let's say, search input, right? And
right.
then this thing will, let's say, begin with a border, and in here you will have some properties for the border, like, let's say, border style, or actually, border style.
So, yeah.
I can do it a little bit bigger there, right?
Yeah.
And in afterwards, you will have the input, and the input will have an input style, right? And instead of destructing this, right, and mapping them manually based by the name,
yes.
what you will want to do is be able to traverse this little data structure. Correct. And map things directly to the component.
Correct.
So that there is no room for you to mess things up, to Correct. Say, oh, I accidentally use the input style in the border style. Yes. Because this one is its own type, yes. right? Even if you have multiple borders, when you define this more general, you're literally folding over the tree, right?
Yes.
This more general fold,
yeah.
you won't be able to say, oh, now I have the three styles, I'm going to reverse them in order.
Yes.
They're just going to fit into the styles that they need to fit.
Yes, and that traverse through the tree will essentially start from the tree of your types in your design system and go directly to JSX.
Yes,
you wouldn't be implementing a lot of details in the components at this level.
No.
The molecule components would essentially not really exist.
Yeah, it will be a little more like there's a main type that has navigation, that will have, let's say, some spacing.
Correct.
And then it will have on the side like the some text, right?
Yes.
This will have some style S, and then immediately afterwards you will have this input, right?
Right.
Let me just move it a little to right.
And then you could also do these checkings, since these structures at each level the nodes are very very specified. Yeah. Right, you could say that a certain node in the tree can only receive one border and one background.
Yeah.
Right, because if you need more, we're going to put the children with more, right?
Right.
And then you could enforce at the type level that certain borders are paired with certain backgrounds.
Mm-hmm.
Yeah. You cannot do that if you're going to have these records saying like text background and label background and so on.
Yeah, I understand.
Anyway, so this is why layouting really matters when you want to go the extra step. So layouting is really the next big impediment in going really, really formal about design. Layouting engines. Yeah, that one I agree. We should do, like, if we go further than this, we should probably do it in a separate live stream.
Yeah,
and talk specifically about the limitations. So, yeah. Because the layouting goes into why layouting is so broken on web, what can be done about that.
Right.
But that we can take as a separate discussion.
It's a can of worms on its own.
Yes.
Okay, so far we essentially have turned a feedback state into an actual text style.
Yes.
For the input.
Yes.
and we have a border style which essentially feeds from the feedback state. This feels a little bit weird, the fact that the style of the border is a feedback state rather than...
Yeah, I think style might not be the best name.
Well, we can rename that.
Yeah.
So this should be a state.
Yes.
Right? And now something kind of cool happens is that when we try to apply our search input, the error that we get from the compiler is telling us we're missing a feedback state of this type, and it's actually giving us the variants that we can use.
That is magnificent.
So now we could say we will render first feedback state for default, and then immediately we can do the error one. We might need to do a BR in the middle. So that compiles. So what we're expecting to see is 2 placeholders, right?
Yes.
Actually, we can do, the error should probably have a value.
Yeah, we can set the
like
value.
Tor.
I think it's a sum, right?
Sorry?
You made an optional for the value.
Yes, I made it an optional argument, which the language automatically turns into an option.
Fantastic.
It's a very nice thing that OCaml does for you.
Yeah.
And so does Reason, right?
Yes.
Okay, so now we should see, on the top, we should see something that shows a placeholder
Yes.
in gray,
yeah,
with black borders and white background. And immediately below, we should see the same thing, but with red text and red background, and Tor in red.
Yes.
So we should see Tor, not command name. Ta-da! No, this is Figma. Okay. And this actually worked.
Wow.
We have the command name in there. Of course, we can't really change it, and this text can be made.
So we need to. Oh, did the placeholder fall in the input?
Yeah, I think. I don't know if we set the placeholder style to be absolute. No, we didn't.
But
if we do absolute, then we need to position it manually, right?
Right. That's fine.
So if we do relative, yeah, it has to be absolute for.
Or you can say pointer events none.
Sorry?
If you want to be very lazy and it works, just say pointer events to none. There you go. So I think we're actually feeding it into the input. That's the problem.
I think I said pointer events to. Okay, you mean the input?
Yeah.
Right. So the input should have pointer events to none.
No. I mean that you.
I'm confused.
Can you go back to the code?
Yes.
There you go. So switch value is using value. And we're not passing the placeholder into it.
No, we're having text. But this text doesn't actually have position absolute, so it's pushing the input to the side.
Oh, right. I see what you mean. Okay, let's wrap this text with a div and set it to position absolute.
So with that block?
No, because the block is position relative. So when we try to do this, we use a different primitive. We call it fixed.
Ta-da! Which would be like the block.
It's fixed now.
But it's called fixed. And the difference is that this is position absolute.
Yeah. The name is search input.
Yeah, sorry. Those are the name strings that we're going to be using in the React dev tools.
Right. So
it might be messed up all over the place. I think I changed it a lot.
Cool.
So now this is absolute, and we have that there, and we have the input immediately below.
Right, absolute by itself is not enough. You really need to set the left and all those.
Which okay, so we would have to position this.
Yes, let's set it to left 0, top 0. And while we're at it, let's set the cent index to -1 as well.
And bottom 0. So doing this on the div, right, makes the div cover the whole thing.
Yeah.
The text still seems to be rendered above, so, which is sort of annoying.
Yeah, that nested, it shouldn't matter anymore.
So if I remove the text, I can't click on the input anyways.
Mm. So what you can do is to set the input set index to 1.
To send it above.
This is not the right way to do it, just to
I still can.
highlight. That is kind of the problem. But
This works.
right, but it's because it doesn't clash with the other one.
And
So
if I remove that, this still doesn't work.
yeah, that's the
sorry.
weird thing.
It might be working.
I think it was working all along, right?
Yes.
Yeah. So what we're going to have to do eventually and finally to accommodate, not accommodate, but to place properly this input text is going to be adding spacings. So we can add one spacing before the input. So we push it a bit from the left and we actually can see the cursor when we're typing.
Like here.
Yeah, exactly. We're not going to do that with padding, we're going to do it with the spacer atom. So we can introduce that. So there you go. And
so slowly we're building up these little properties, and I reckon the spacer will take spacer style, which is defined in the design system, and it's going to turn it into CSS.
yes, I think it's a size almost literally.
Maybe size. Okay, so if it's a size, then maybe we can just turn the sizes from the design system straight into the CSS atom.
Right. This is what I think.
I forget what is this? Particle.
Yeah.
CSS or particle spacer size.
There you go.
Let it be known that this size at the design system level, right? It's a spacer size.
Yes.
Gotcha.
And
we want this to be. But it's just gonna have some other properties,
yes,
right?
definitely. It's going to have right. It's going to be the same size on width and height. So we can either reduce that value or simply say that spacer size is it's a combined, so it's fine. Okay, cool. No, then that's it. Actually, that's all we need. We could have, if you want, for debugging purposes, we can add a background color to it that we toggle with a property to make it visible or invisible. This is something I often do, but we don't need to, and in this case we can easily inspect with the inspector. Okay. This is especially useful when you have many of these. Right. Like you want to see them all throughout the page.
So now we just need to...
Correct. So XS is going to be 5, S is going to be 10, M, I don't remember where we got this from.
Oh, actually, my bad. This shouldn't be particle. We actually have a spacer in the design system.
As an atom?
Yes, that has the things that we need. So we just need to give it a width and a height. And
I don't know why we have width and height. I suspect we should only send one. Yeah. And I don't know if we really need to store width and height as part of the type, since they're going to be the same.
Maybe we can simplify this.
Yeah, let's do it.
Just say this will be size.
Yep.
Is there any case where we will have spacers that are not square?
I mean, it could be ideal if they occupy the entire available space regarding vertical or horizontal, but then we have to do very complicated calculations to know whether it should be horizontal or vertical, which is a bit pointless for our use case. So if we have square ones, we can use them either for vertical or for horizontal anyway.
Exactly. Okay, so here we have a size that you pass in,
yes,
and then just out of the atom, and then spacer, and then make, and then we will turn this into atom spacer to CSS.
Correct.
It slowly becomes this sort of mantra that you repeat, like
Yes.
You take a primitive value, you turn it into a design system valid thing, and then you turn it into CSS.
Exactly. First the primitive into the corresponding level, then the level into the platform specific.
Yes. So is this a scale?
Yeah, I'm guessing so. I don't know why we had all of those. I don't know if we even need them, and there is no specification for that in Figma. But let's go for it.
Okay.
So they're going to have to be pixel, right? So it's 5px and so on.
Immediately.
Yeah.
Size, and then what we return is style, that make. What kind of style are we returning?
Width and height.
Right. So we set the width to be particle.
Right. You're going to
size.
Yeah. Yes. And the same with the height. Yeah. So in there you are doing the shadowing on the of the variable, right?
Yeah, yeah. This is not mutating, it's rebinding.
Right.
Looks like the same thing, very different.
Yes.
The record pattern is expected to have type. Of course, this is spacer. And
What is the error?
it's telling us. Alright, it doesn't. My bad. So I tried to deconstruct this T, but in reality, I don't need to.
Right, right. It is simply the size that we're sending in.
Yes. So let's see if the inference works best when I don't. Okay, it works the same way. So essentially, I have a size, which
Yes.
of course net tooling is not working for vocal script. That will be one of this, right?
Right.
And the particle spacer size
Yes.
is taking one of those and returning a string.
Yes.
And it's telling me that somewhere it wanted something that goes from spacer.t into a type B.
What is that type B?
It doesn't know. It's it could be any type.
Right.
So what I'm guessing is that this binding actually didn't do the thing that we expected it to. But it also, it's not like it worked. It's not like the name of the variable is causing the trouble, because when I call the same thing, it keeps failing.
Right. So it's not the shadowing.
Exactly. So the spacer size is defined for all of these different variants that we have. We definitely have the type system here, right, for spacer size.
So it is exhaustive. It's not missing anything. Then the T of the spacer is that. Right. It does not have access to that one.
Oh yeah, you're right. Yes, it's yes.
That's why it was like B, like this type. I have no idea what it is.
So I'm just gonna.
You can either do a
that.
view or yeah, exactly.
I think for now.
Cool.
Yeah, and that got us going. So in the
So
spacer,
the type was private before.
Precisely.
Now it's public. So now the function that does the mapping can access it.
yes. Now we have a spacer. And this one in particular actually takes size,
Do you have to build? Ah, no, right.
and I don't like that because the other ones don't do that. The other ones just take a style, don't use name arguments for that.
Right.
So if we remove that, then it compiled. I don't know if anything should change.
Right, we didn't add it yet. So what we need to do is in this search input molecule, we need to add this spacer, right. And we're going to add a spacer of size extra small, which is going to be 5 pixels. Extra small is the minimum size of the grid. We're going to also add it before the input. Right. So if we wanted, we can wrap the spacer and input with a fixed, so that they also become a layer on their own.
Right. Oh, that's really interesting. When you think of this as layers, right?
Right.
You're sort of lifting components that are in a component into its own plane.
Exactly. So the way that this suggests for thinking about layouting, right. So what happened now is that the wrapper is no longer taking the layout from the input anymore.
Right, exactly.
So that's why it's collapsing, which now means we have two paths forward. One is to set the height manually.
Yeah.
The other one is not to do the fixed thing for the input.
Right.
I would suggest to set the height manually, because that's what we actually want for the input. Should not have a flexible height. So in the block that is wrapping the search input, we're going to set the height.
Here.
Correct. No, not style. The block is a restricted primitive. We don't want to have it take any style whatsoever. We want it to support the height and the width, but nothing else. So we're going to put height, and let's set the height to what the specification says, which is 70 pixels. You want to use a fixed size, don't you? Like something from the enum for the size. Yeah, right. So, and that could be so if we were specifying the molecule with all the layout constraints as a type.
Right.
But
Which we
right now,
yes.
what are you trying?
I am going into Twitch on the phone.
I have it here.
Cool. Is it the sound?
I don't think there is sound.
I am going into Twitch on the phone. I have it here. Cool. Is it
No, I think it's fine. It's just fine.
I'll just double check the volumes on the phone. Oh, is it the sound?
I don't think there is sound.
That is good.
There you go. Very
I was
meta.
like, holy crap, how long have we been talking, just like moving around the cursors, and there's nothing that actually tells you what we are talking about. I'm actually gonna post, if you don't mind, the picture that I took of you explaining stuff.
Sure, no worries.
As we continue with this.
Do it. Yeah, I think as this gets more through time, we probably should have the headphones to listen and find out if it's actually propagating the sound.
Yes, yeah, and it would be very nice to have at least two cameras pointing in different angles so you can do cuts and stuff.
Right.
It shouldn't take that much. You know, like I even have a GoPro here that I tried using for streaming purposes.
Right.
But it's quite a weird setup. You need to stream into the network and watch it through VLC. So that in your screen you capture it.
Yes.
Which is kind of odd.
Yeah, I do understand though. Like this type of IP cameras are usually streamed that way. They're using very low level protocols, so you're not getting them through a website. I had one once, like it was an installation of a security cameras, so I got to try one of those IP cameras for infrared, and it actually had its own kind of website hosted in the camera. But
right.
It was not the best setup.
They usually really
want to. Sorry?
They're usually really bad. Like
exactly.
They have low frame rates.
Exactly. So you want to feed more raw directly captured via another system. So it makes sense. Like something like VLC that is working with low level protocols and can usually go through something more optimized in the wire.
Right. Okay, so I posted there.
Cool.
People can see your face. Hopefully that's okay with you.
That is
and fine. We can continue. Yeah, we also probably need to get some better microphones to capture the voices more clearly.
Don't yell in people's ears.
Yeah. All right. So we said that we either want to use the block height, right?
Yes.
So I have a suggestion.
Yes.
We already have sizes, t-shirt sizes.
Yes.
XS, S, M, L,
Yes.
XL.
Yes.
Does it make sense to define blocks in terms of those sizes? Like there will be a block, there will be, let's say, the small block.
Right.
And it has these sizes.
I am not sure. I never tried that. I don't know if, as a general rule, blocks are systematic enough in their sizes for that approach to work. I have mixed feelings about that. I suspect some block types do, but some other block types, depending on wrapping of lines, multiple of text in multiple lines, for example, or of some other type of content that they have inside, and then you're easily going to get into a situation that you have some padding sizes plus an item size that you repeat. You know what I mean? So imagine that the padding size is 10 pixels and then the item itself is 20 pixels.
Yes.
Then the total size of the block is going to be 30 pixels, which is fine. You can say, okay, that's an easily encodable size. Now, let's say that the item actually it's like a radio button, for example. You have many items or a menu. So you have the padding of 10 plus 3 items. Each item is 20 pixels. So it becomes 60 for the item sizes plus 10 of the padding, so it's 70.
Right.
So is that also going to be one of your t-shirt sizes?
No. I guess that I would say that off the top of my head you have fixed and fluid sizes, right?
Right.
And for fixed sizes, the t-shirt size is the maximum size it will have.
Right.
And for fluid size would be the minimum.
Aha.
Does that make sense?
Yeah, that is
like when it's fixed, you say it's small, it's going to be this height.
Yeah,
it can't be less than this.
That is an interesting idea. Yeah.
I'm not saying that we need to explore it now.
No, but it's a good comment to make, because the moment you hard code any particular size or data of this kind into the molecule level, you know that there is a leak on the abstraction.
Yeah.
The molecule level is supposed to be very removed from the atom implementation details. As we said though, that the layout tends to be an exception because layouting is not so well formalized. So it's not a surprise that the moment we have to kind of like break the abstraction is precisely when layouting.
Right, that makes sense. Okay, so let's go into the block very quickly and add this height.
Yeah. Which probably be an optional. If we don't have a height, we need to let it to auto.
Okay. And width.
Correct.
If we do have one, we want to use them. So we can, because we're just making a style here, we can just do something quick and dirty. I'm just gonna make an opening of the module there, and we're gonna call combine. And I think combine just takes two different styles. So here's what we would check if height exists, right? Switch height. This is definitely not the nice way of making it. If there's none, we just use an empty style. Combine will get rid of it. Right. And if there's some, then we will just get some value, and here we'll make height.
I mean, this
X.
You're treating the styles as a monolith.
Yeah, exactly.
And the combine as a concat.
Exactly.
Yeah, makes sense in a way.
I'm just trying to get it out of the way.
Yeah.
And then we do another combine above. This is missing something. Line 19, block. There you go. And of course this is missing the parentheses, the unit. Boom, that should compile. Alright. I expect this to still be broken, but look at that.
It is not broken anymore.
It is not broken anymore.
Perfect.
That's brilliant.
Yeah, that is really nice. That is good news. So let's zoom out a tiny bit. I think we have an input. We had a small alignment issue, right? So
yeah, we're trying to add the spacer on the left.
Right. So what's happening now? If you look at the, where are the spacers?
I think, did we add the spacers? Yeah, spacer size XS.
Right.
And we should have something here. I'm gonna open the React Dev tree, which I don't have. Brilliant. I should have had that, but I guess if we go down to,
Oh, but it's fine. We should be able to find those
Here.
divs.
it's a 5 by 5 div, 5 pixels by 5 pixels. But if it's not position relative or absolute,
No, we shouldn't need to do much. I'm confused. Yeah, I know what the problem
Oh.
is. I was.
it pushed the input down.
Yeah, which is fine. Right. We
instead of
wanted
the
to
left, yes.
move it to the left. Okay, so we need to add 2 extra primitives. This is going to be fun. We need to add a row primitive and a column primitive.
Right.
And you are going to guess what they have to do, right?
Yeah. So the row one is essentially going to be a spacer. I mean, no, it's not going to be a spacer, but it will have properties that will align them horizontally, like inline
Correct.
block.
Correct.
That's actually just what I added to the spacer,
Right.
and it did exactly the right
Yes.
thing.
So we're going to do it with the flexbox, but yes.
Can you mix around Flexbox and the box model?
No, but we're not going to. We're just going to use flexbox.
Okay.
Like the other things that we use are fixed size, position relative,
Yeah.
and no size, position absolute. Sorry, covering the whole thing. So
right.
currently our layout primitives are one thing that will get size from the context or from fixed values that you pass in,
Mm-hmm.
which is the relative, right? It's the container. Another primitive, which is the fix, which will be position absolute and cover the entire area that it can cover.
Mm-hmm.
And now we're going to introduce 2 new more. One that is going to be a row.
Mm-hmm.
So elements that you put inside float from the left to the right as you put them in. And another one that is going to be a column. So elements that you put inside are going to float vertically as you put them in.
Okay.
So let's add the row primitive since we need it right away.
So how will we use this row in this particular scenario?
We put it inside the fix, right?
Right. So we say fixed, which means this is its own layer.
Yeah.
We say row, which means everything inside of the row will float left to right or right to left.
Yeah, so row will have that direction implicit. You could add the property to row saying reversed, in which case
Right.
you flip the
left
direction.
to right
Yeah.
or right to left.
Yeah, you choose
Okay.
that. Right now we're going to go with the default so we don't complicate the row primitive.
I would say that you're making it simpler.
By passing the direction.
Yeah.
Right, because it doesn't have to assume anything inside.
Exactly.
Yeah, cool.
And we want to do the same thing for this one over there.
Correct.
Now, interesting problem for you to figure out is how do you make sure that this direction and this direction are the same direction?
Yeah, right. I mean, this is exactly the layout abstraction that we're lacking.
Exactly. Okay, so let's do a row. We can begin with the block. Actually, the block is very complex. Let's just use a spacer. Source,
Yeah.
Row. And then we will have a direction.
Yeah.
Okay, so I assume that this will just be some styles.
Display flex.
So switch direction, and this is how we actually tell the type system what this if function is expecting, right? Left to right will be React RE style will make off.
Flex direction row. And there is a reverse. Flex reverse, I believe it is. Let's see, CSS tricks. I have it always there.
It's a row dash reverse.
Okay, there you go.
So this is a row, right? And then for right to left, it's row reverse.
There you go. So we also need to set display to flex, but that we always need to set.
Okay, so then we can just do a combine.
Correct.
Oops. Display should be flex, right?
Yes.
And actually this should be a make.
Right.
And then the other would be the direction, which is one of this, because we have already that over there. This should come to this. And we should have what? I think this should be all. We're missing parentheses there. What other default properties do we have?
That's all.
Cool. And I reckon that the column one will be very similar.
Yeah, extremely similar.
But instead of left to right or right to left, we'll have like bottom up or top down.
Yes.
Okay. And they have column and column dash reverse.
Yes.
Cool. So now I expect the inputs. Ooh. Did something go wrong?
So it is possible that they have to be set width and height 100% for this.
Which ones? The row?
Yeah, it is possible. Flex has it's very idiosyncratic.
You can take a look at that.
Yeah.
So actually, the problem is that we are not passing
The
children.
The children. Yeah.
Yeah. Yeah.
Could somebody think of the children?
Exactly.
We forgot about the children. We're terrible people.
Cool.
There you go. That was
And now
easy.
I can actually see the.
Yeah. So another small mistake I made is that it's not supposed to be 5 pixels. Our grid has been 10, not 5. So we can
That's
pass S instead of XS. That's fine. We can leave it there. Well, that definition right now violates our grid, but it's not terrible. Yeah. There you go. So what we would like to have probably is the same alignment vertically of the text and the input.
Right.
To do that, we're going to have to also change the line height of the input. No, we already did that.
Mm-hmm.
So yeah, this
Actually,
is
the input.
right.
Does the input have a line height?
I think so because we copy pasted the styles from the atom.
Yes.
Let's just check just in case. But
So no, the text has it, right?
yeah, the text
The
has.
input has it too.
Yeah. So because of how the span and the input are treated different by the browser,
Mm-hmm.
one got a certain box size out of that line height and the other one just didn't care.
Right.
The input didn't care. So we're going to have to tick them until we align them the same way inside the respective boxes.
Question.
Yes.
Can we use another input for the text?
If you want to. Yeah.
So my question here is,
I know what you
it
mean.
will use the same properties?
Yeah.
If we render it afterwards, like one layer below,
Yeah.
and we say pointer events none,
Yeah.
then it will be able to show everything?
Yeah.
What will we have to do otherwise?
No. We will have to manually adjust the atom text to have the same footprint as the input,
Right.
or vice versa, which is a lot of small tweaking manual work,
Mhm.
which is totally doable, just a bit painful.
Okay.
If we want to just eyeball it right now, we probably can start adding spacers on top until we hit the same position.
You mean like
Yeah, so what we will
Now we
have
need
to
a
do
column,
is to
yeah.
wrap exactly. We wrap the text in a column and we add a bunch of spacers. Yeah, either way it works.
and then in here you would put the spacers.
Yes.
We can put one and then add as many as we need.
Yeah.
Uh-huh. So it's worth noting that to be able to use the design system, we don't actually need to make all these primitives, right?
Right. Ideally, these primitives will come from somewhere else, and technically, you just don't need any of what we're saying in this stage.
Right.
This is just to highlight that we are building pieces that are faithful to the design system. So there is a very transparent way of doing the transformation, even if it is not yet fully automated. So
Right.
a fully automated transformation will start from a tree of pure types from the system and do a traverse until it generates a React DOM tree, a React element tree.
Right.
We are not yet at that level, but we can approximate closer and closer to that. And these primitives allow us to get closer and closer to that.
I think something very interesting to note is that most of the things seem to work immediately after they compile.
Right. Right.
Like I just added the column, for example, right?
Yeah.
And I already know that this is smooth. Like I can
Yes.
tell visually it has smooth.
Yeah.
There's a different issue, which is finding where the hell the element ended up at,
Yeah.
right?
Yeah.
But so we have the column there, and we have the style.
Yeah, it's very robust, and what's also happening
this
here is
like
I know.
you're gonna have to do something dirty here.
Yeah, probably, because I mean, if we align the footprints, then we don't have to do anything dirty. But
Yeah.
I don't think we're going to work to align the footprints perfectly right now. Another thing about this is that it's extremely robust because we're only using position absolute, position relative, and directions of row and column, and widths and heights. We are not using paddings and margins ever, which are the ones that have problems cross browsers.
Right.
So the implementation of this elementary subset of JavaScript is extremely consistent. So a lot of the of JavaScript, of CSS, a lot of the ugly parts of CSS are actually due to the feature bloat that it has. So if you try to go into advanced features of Flexbox or of Grid or even of the basic box model, you're going to find out a lot of cross-browser mismatch.
Right.
But if you're doing simple position relative and position absolute and simply direction in Flex, then it's way more likely you're going to be consistent. Right.
Yoga layout is something that Facebook came up with to say, fuck the browser implementation of the Flexbox.
Yeah.
Let's use the same one across all devices.
Yes.
It's definitely not perfect, right? But it's a better step towards standardizing how they behave across the browsers.
It is closer to what we're doing right now, actually. And it is following the Flexbox model too close for my comfort. But it is definitely more interesting than the simple CSS layout. Yeah.
Something interesting note as well is that there is a Flexbox implementation written completely in. Okay, I'm just gonna search for it. Flex ReasonML. Completely written in Reason.
Right. So you can reproduce that type of layout things.
Yes, exactly. So that might be something that we could use at some point to redo the layouting.
Right.
Keep the design system as it is, right?
Yeah.
And try to represent the layouts with essentially this other set of types, defined layouts.
Right.
I don't know if they're composable. They might compose just fine, or maybe not.
Yeah. So I'm going to go into this the next time when we do the conversation about layout issues in particular. But unfortunately, it's not going to be enough either. Flexbox is also fundamentally broken.
Okay.
And Yoga is also fundamentally broken for the same reason. I know it's a big claim, but I can prove it when we go into it. So we can go into what the issue is and how to fix it.
Okay. But do you have any off the top of your head?
Yeah, there is a feedback between what you're rendering from the top down, and when you actually get to the text, you get a bottom-up layout restriction that comes from the text size.
Right, so the whole of the line breaking is defined by the layout rather than the layout knowing what the line breaking is expected to be in.
Right, so the layout fits into how the text is going to supposed to be rendered, and then the text fits into how the layout should be presented.
Right.
And this is done at the render level of the browser, so you don't have access when you're predicting the layout. You cannot predict what the layout is going to be. It's fundamentally non-deterministic because of the way that the browser implemented text rendering. This does not have to be. Text rendering is deterministic by itself. If you want to have a chunk of text and you know the restrictions, you can predict how it's going to render. but you don't have access to any API to get that information
from the browser.
From the browser.
So to be able to essentially fix something like the Flexbox model, right?
Yeah.
You would have to reinvent or let's say re-implement. I mean, we both are aware of the Donald Knuth work on breaking lines into paragraphs.
Correct.
You have to re-implement that, so you'll be able to tell for this particular piece of text,
Yes.
the particular space that I have, these are the layouting constraints that I need.
Yes.
So then you can feed that back into layout like Yoga, but you would have to redo the whole. Sorry. You'll have to redo the whole rendering of the text as well.
Yes.
So you have to drop all of the primitives from the browser and kind of just go, all Canvas or WebGL.
Yeah, I mean, if you can calculate it with the same algorithm that the browser uses, you don't have to go into full Canvas. But if you can calculate it, you might start wondering, why do I have to use the line breaking algorithm of the browser, which is the most simplistic and boring one? You can go to a far more sophisticated text line breaking algorithm like the Knuth Plus paper, which is the one actually used in InDesign and the one actually used for more scientific papers.
LaTeX or LaTeX.
LaTeX, LaTeX. So it is, it is a rabbit hole, but at the end of that rabbit hole, it turns out that for layouts to be truly deterministic, you cannot rely on any CSS whatsoever. You need to redo from scratch because there are no APIs for getting all the required information.
Right. Interesting. If there hadn't been a sort of declarative style sheet language, but rather a set of APIs for JavaScript, maybe we would never have had these problems.
Well, you can see it that way. Another way that you can see it is that the declarative style sheets could be parameterized by the sizes that the text is going to provide.
Right, yeah.
Right now, we don't have any way of finding out what the text size is going to be and use that parameter, right? Because you have variables in CSS right now, and we had for a long time ways to kind of parameterize a relationship between things in CSS, like sibling selectors, for example. It's not like you are not aware of any context around you. Like you even have child selectors. You have a lot of ways of elements affecting each other.
Yeah.
But CSS does not have access to what the size is going to be after the text renders.
Right, exactly. So you just specify this is what I want, but you may not get that.
Exactly. You can say a mean height, or you can say a fixed height and then set an overflow, but you're not going to be able to anticipate what the height is going to be.
So as a small spoiler here, I actually set the text to be, I think this is fitting.
I think so.
This is one 10 by 10 block and one 3 pixels block.
Well, that is the padding that we could probably have to set either in the text atom or in the other, or in the input. Either way, aligning to the grid relies on this small pixel fixes with padding top. That is essentially how you do it.
Gotcha.
But we're not drawing the grid right now, so it sounds a bit empty to talk about the grid alignment.
Right. Like I guess it will make some sense to sort of drop in this 3 pixel column just to make this work, since this is less about the grid alignment, a little bit more about the user seeing something that is completely wonky when he starts typing. It's like, oh my god, what is going on?
Well, to be fair, we should make the text disappear the moment you type.
Right.
But
I think you will still notice. You will still notice that.
The brain is very smart like that.
Okay.
Cool. So, what do you think? How should we proceed? So we fulfilled one of our goals, which is to have the field, the input field, search field. Sorry. We
have a molecule. I think that if we manage to get the navbar, and given that we have the spacers and we have the rows and columns to throw in, I think it should be fairly straightforward to put it together.
I completely agree. So we need to do only 2 pieces for that. We need to do a title molecule that is going to be very, very simple because it will only contain a text atom parameterized with a fixed style and the fixed text inside. So let's create that molecule. Probably not copying this one, right? It's going to be simpler to copy an atom molecule. Yeah, this one. It's going to be very straightforward.
this will be a title,
Correct.
and this will ignore the children that you pass in, right?
Yes.
And it will have a text, and the text will have a very specific style with no overrides.
Correct. It's going to be main and with the black variation. The fact that this part is fast starts highlighting how all the preparation work we did is actually paying off. So that's going to be a TLDR. I think there is a small syntax error. The slash under there. Good. That's
and
good.
This has to be a recent React string.
Yeah. So this one should have a fixed size actually as well. So let's surround it with a block. It's going to have a fixed width that is going to match the TLDR text. If everything goes well, that should be literally 90 pixels in width. And the height of this should match this height of the input so that we can put them side by side and they align properly.
Oh, perfect. I forgot that I had the width there. And the height should be 70 pixels.
Right.
Yeah, we definitely need to abstract those heights away so that we have two constants that are related, but they're magically related.
I see what you mean. Well, this is a navbar height, so yeah. We keep going back to layouts. It's such an interesting and useful topic. Yeah. Cool. So now what we're going to have, actually the TLDR, probably we need to push that text a bit down, but let's not care about that yet. Yeah, exactly.
It's been rendering now.
Look at that.
Okay.
Yeah, we're getting close. So
well,
now we need to introduce this navbar component, which is going to be our first organism.
Oh, okay. So source, navbar, RE, and the navbar is not going to take any state.
Nothing at all. I mean, it should take the value on the unchanged if you're thinking application level, but we can skip that for now.
And we can just lay down some static things.
Exactly. So we're going to need to set a row, and that row will have the title, then a spacer, and then input.
Left to right, and this will have essentially the title, and it will have the search input.
And the spacer in between. And we do not have a spec for how the spacer should look like, but I would go for a medium.
Yeah, that was my call as well. So if we do this, what is it that's wrong? Did I say this?
I think search input has required mandatory properties. You mean syntax byte?
Yeah, it's failing at the syntax level. So line 9. Direction, left to right, row. It's in the navbar. It's definitely in line 9. If I remove that, that works. So there's something here
Let's
that
have one by, let's have one by one.
And then we've set a spacer of size M. And then we said search input.
Yeah. Okay.
That worked.
Yeah. So
so we don't need a feedback state and a placeholder string.
Right.
So I guess we can just say placeholder, and this of course could be a translation key to your favorite, key value table. Yeah.
So just command, and we're using lowercase here, so command name. There you go.
And then we also need to have the feedback state.
Yeah.
But we can pass that in as a property.
Yeah.
Right. So that then we can render two of the navbars and see the different,
Perfect.
sorts.
Perfect.
Oof. Okay, so let's put them in the index now. I'm gonna remove all of the search inputs.
Yeah.
And I'm just gonna do navbar, and this has a feedback state of error, and it should have a feedback state of default. And if we refresh, wait, this is too big.
Right. So what's happening now is that the width of the input got collapsed. because once it's submitted into a row, it doesn't know what width to take. We need to set the width. So let's set the width to be 100% actually.
In the rows?
In the search input. In the block of the search input with 100%. Yeah, that should do. If it doesn't,
it feels like this should be the default for a block. But
no,
I'm not sure.
how
No,
to is
maybe not.
better. Yeah, there you go. Cool.
That worked. Now this one small problem is that this is taking.
Right. So it's not really 100%.
Oh wait, it is 100%.
Ah,
It's just that I had zoomed it in,
okay.
and
okay.
when I zoom it in, then
That's
of course it
interesting.
moves to the side.
Right. So there is something about the spacing there. So the width of the TLDR seems to be a bit off, but
So
what's
right,
actually
it's-
wrong is
it's
that
too
the
small,
spacer.
the width.
Right. Okay, it's coming from Figma. It might be some misalignment. Let's make the TLDR a bit bigger in the width. Let's set it to 80 instead of 70.
So this is 140. This is 80. I think we're gonna have to go all the way up to.
No. Mind that we shouldn't include the spacing in between them.
Oh, okay, right. You're correct.
That is the role of the spacer.
So I'm at 110, and I'm needing.
Oh, you need to have space between the JSX elements. That's why it was failing, says Ulrich.
Really?
Yeah.
Oh, I didn't know that. Thanks,
Yeah.
Ulrich.
Thank you.
Thank you so much.
Yeah,
So 120 seems to be the space that we have.
cool. Let's go for it.
Someone's asking me why I stream on Twitch instead of somewhere else. Well, I had a friend. I'm sorry, I still have that friend who works at Twitch, and one day he said, "Dude, you should totally stream on Twitch." And I said, "Fine, I'll give it a shot." And I started, and I'm a creature of habit, so I built a habit around it, and now I'm here. I'm thinking of streaming on YouTube as well, but I haven't figured everything out around it. It will take a while though. That's really the reason. I'm just too lazy.
I can also say that Twitch has a really nice design system.
Yeah?
It's based on Sketch, I think also on Abstract, and they have a React. I watched a presentation on Nordic Design about it. It matched more or less our setup. So.
Cool. Right.
It
Oh,
makes
nice.
me-
Very, very nice. Okay. So that's another reason that I didn't know about. Those are reasonable reasons to use it, I guess. So the width should be about 120, right?
Yeah.
So we
let's
can
fix it to
in the
120.
nav bar. That's right, in the title component.
Yeah.
120, which should fix this.
Yes.
Right, and then there's some height here that we're not including because we did not include the essentially the.
Right. So what we can do is we can set a column around the text. In
The same thing that we did for the rest,
Exactly.
right?
Exactly.
So column, spacer size,
Correct.
bam, and then we do column.
Voila.
That
Good.
was so nice.
Yeah.
Okay.
And the last thing I could do is to make the space in between the TLDR and the field a bit bigger. I think that the space sizes generally reflect the hierarchy. So now they feel like the same thing, and they are not really the same thing. So we want to make the spacer size to be extra large, probably.
Right. One sec. I'm actually passing in a command name as the value for search input.
Right.
Because otherwise it shows red.
And so you're going to have the small issue that because it's the default value, it's not going to hide. I'm not sure what I'm saying. Do you mind switching back the spacer to XL then, in line 10? That one. Cool. Thank you.
Well, so here what I want to do is essentially a switch on the command name, and if I have none, then I will. So how do we do this? How do we pass in a property that's none as none? Interesting. So we know that command name, right, is going to be an option of something. We know it's going to be a string because of how we call this in index. We're going to say command name. It's going to be Tor. Right?
Yeah.
But the search input, it's expecting a value that may not be there. I guess that if we don't make this optional, sorry, the parameter doesn't. It's not a.
It's not an option.
Well, it's an optional parameter, but it's also an option, right?
Right.
For now, it's a mandatory option,
Right.
where before it was an optional option. Does that make sense? Like type optional.
Yes.
Okay. So here that works essentially. Why? Because if you're specifying this parameter, right? That means with this syntax,
yes,
if you call make with a value, they will expect the value to not be an option, but to be a string. If you don't call it with value,
yes,
then it says, oh, value should be none. But if you're giving it a value,
yes,
right, then you have to give it a string.
Yes.
And in this case, command name may be none.
Okay.
So like the unification will end up as with value being an option of an option string.
Right. And then you have to chain it. Or
Exactly.
something like that.
But that works over there. So now if we go back, we should have.
So you could also give it a default in the properties. Set command name to empty string.
Yes, absolutely. But then you mean
right? You want to use the sum to determine whether or not we render the placeholder. Right?
Exactly. Yes,
right.
that's what I want to do.
That is why we don't. So we could switch on the string value to render the placeholder if the value is empty string, but we feel it's cleaner to just have an optional. If you do have a value, then it should be just something.
Exactly. Yeah.
So technically, you could have just empty string. So that's a bit of a bug there, but we should like just with runtime logic make sure that doesn't happen.
Maybe
On the on change. Yeah. Cool.
Okay. So that encodes the nav bar.
Yeah.
For both cases.
Yes.
And we have all of the other texts here. This, of course, don't look nice. They're not meant to look nice with each other in this way.
Right.
I guess we can remove all of that crap from the index.
Cool.
Slowly we're building up the application, right?
Yeah.
Can remove all of this.
Yeah. If you want to do some very cheap extra thing, you can put a detailed text, like a full paragraph, out of TLDR, the welcome text.
Oh, that would be nice.
And put some spacing between that detailed text and the navbar.
Right.
So in that case, we will turn this into a column. This is what I could call the ecosystem level. So you're putting together organisms. And here you put a big spacer. So, we don't have a level about Excel, so let's just put 2.
Yeah, that makes sense. Okay, and here I guess we can begin with a text, and then we can try to fit that into the model we have there, because we do have.
Right. Because we need spacing in the left, and we need a lot of other things.
So I figured that maybe we can just begin by throwing it some text, right?
Yeah.
Like
of type detail. Yeah.
Do you have a string that you want to share?
I want to lorem ipsum, but otherwise I could go to the TLDR website and copy the intro text. We try to learn. Okay.
That's an image actually. Let's pick something that's pure text.
Okay.
Thank you, reformat. You're not helping me write these bits.
Yeah, I mean this is module paragraph, right? So. Yeah. So it should be detailed.
Right. It shouldn't be made black.
Exactly. Yeah. And also we probably should have several instead, but that's fine.
We can duplicate this in a few. There's something interesting is that the text seems to be collapsing with itself here. Like the line height is not.
Yes, there is something off
enough
with your line height. Was it 20?
Well, here it's 15, but it's less than the font size, so it makes sense that it collapses, right?
So it's 20. Should be 20. The line height.
Yeah, if you do 20, then you have 20. Oops, 20, and that is readable.
Right. The size should be 15. They were reversed. This is what's happening. Right.
Oh, okay.
It's probably happening everywhere actually, because the text looks too big. The text inside the command if you compare to Figma.
Right. So when I extract this should be the font size and the line height.
Mm-hmm.
So essentially, this is where throwing pics here would not help, but throwing like font size like that will allow us to pattern match on the right things.
Right.
And then we just need to throw the polyvariants around these things.
Mm-hmm.
And so we can replace the open with an open font size, right?
Mm-hmm.
And the nice thing is that after this, right, the type of this function becomes give me a style or a font size, and I'll give you a tuple of font size and line height. So if I do comma space.
Glass of Ethanol is asking if ReasonML is a good replacement for OCaml on Windows.
So I think Ulrich in the chat might be able to give you a really good explanation of how to use OCaml or Reason on Windows, but essentially both share the same underlying tooling. Reason is just a new syntax for OCaml.
So that could mean that it's not particularly better than OCaml in Windows, right?
Not that I'm aware.
Right.
Okay, now we have some trouble.
Because the VS Code setup that you can have for ReasonML, you can also have for OCaml, so it doesn't also change for VS Code.
Precisely.
Right.
So this looks much cleaner now than it did before.
That is approaching quite closely to what we want.
There's a small problem
clearly our
with
design was not perfect.
Yeah. Absolutely. I think now we might actually be able to do the things we want with.
Do you think the alignment is correct?
I think it might be correct. Right now it's completely off because the input field doesn't have the right. I think line height. So the input field over here, right?
Yeah.
Is a little bit off in respect to the text that we have here, I think. Yes.
Yeah. So I mean, if it happens to align between span and input, it's entirely coincidental. It's not robust. So.
But I'm saying that now that we change the font sizes, right?
Yeah.
The input itself has gone bananas.
I am not sure what you mean.
So before the input looked right, and the command name we had to move down.
Right.
But now we kind of have to add more vertical spacing.
Okay, we can add spacing on top of the input to try to make it match a bit better.
Right, exactly. I think that I'm just gonna replicate the same thing that we had before.
Yeah.
Sorry, the same thing that we have for the text.
Yeah.
If that makes any sense.
Yeah, it does, absolutely. It is expected actually, it's just that probably the bounding boxes, the footprints of the text and the input are not going to magically match, and they do.
They do.
They
match.
That is brilliant. Yeah, I know. Yeah, okay.
Dude.
That is really good. Might not be cross-platform, but this is really good start.
This is brilliant.
Yeah.
I hate the double M's of Roboto, but this is brilliant.
the sum versus just is not really working. Otherwise, you couldn't overlap.
Sorry?
If you start typing, it's not really working in the optional.
Yes, but remember that we haven't hooked the value back into the component.
Okay.
We're not re-rendering it.
Right.
If it were, then it should just work, which would be nice. But
yeah. Cool. I think this is really good progress. I'm not sure how you want to drive it forward.
I think that the last thing I would like to do to say that we actually built one ecosystem is to add the spacing on the left side of the body.
Right.
So that it fits, it looks more like this essentially.
Right.
And perhaps we could try to center the whole thing.
Right.
If we do those things, then I think that we will be just very,
Cool.
like we have a whole page.
Cool. So let's do the bottom side then. Let's call that content or something like that. I think we can call it textual content or something similar. As a molecule, right? Sorry, as an organism. We're composing the text of the detailed text together with some spacing.
Right.
So we're again breaking a bit the hierarchy because we are going to be using an atom directly in an organism.
Right.
We shouldn't be doing that. What we should actually have is a detailed molecule that receives an array. Let's do it actually, it's not that hard. We should have a detailed text molecule, right?
Yes.
Or just detailed molecule that receives an array of paragraphs. And then for each of those, it renders a text atom separated by spaces.
Right, exactly.
So
Using the right space. Yeah, that makes perfect sense.
This is what we need to do. Let's do that, and it's going to be cleaner as well.
So
because right now all the text is mushed together in one sentence.
Right.
Yeah.
So right now it receives paragraphs.
Yes, which is going to be a list. And then we need to map over that list to put it into a text, and also to put spacers in between. So the map.
Brilliant.
We need a fragment essentially.
Okay, so we will begin with the parse, and we will just list map over them, right? And then we will get each one of the paragraphs, and that's what we're going to be feeding into the map. Okay, so this is what I have so far. We have a block. Do we need a block here?
For the detail, no, we don't. We don't know the height actually.
Right. It's fluid, precisely. Okay.
Right.
We do need, however, a column so that
Definitely.
things go.
Yes. We don't need a top space. Right. We need in the organism, not in the molecule. So as a rule, the molecules should be like top to bottom, left to right. No paddings, essentially, no spaces inside. The spaces are in between components, not inside.
The organism is the one that decides how to place
Exactly,
it.
exactly. Okay. And you give that flexibility by not setting any.
Yeah. So in this one in particular,
yes.
What would this be? Would this be the detail molecule?
No, you're defining the detail molecule now, right?
Okay. And the detail molecule takes a bunch of paragraphs?
Yes.
Or is each paragraph a detail molecule?
No. It depends on how you think about it.
Right.
Either works. In our case, it's more convenient to make the molecule contain many paragraphs.
Right.
So
I think that's what
that
works.
way. Yeah.
So between each one of these elements in a list, right?
Yeah. We need to interpolate a spacer. So you can do it with a fragment if we have fragments. Otherwise, we can just put like another column or a div.
But do we need to have a spacer?
In between the texts, yes.
Right. So ideally, what I would do is map over this and then have a function that will put things in between the elements of the list.
Yeah, with a fold or a reduce or something.
Right, precisely.
Yep. That works.
We can definitely do a fold here. Fold left, and then we have the accumulator and each one of the elements, and we just return the spacer first, right? We just give it the size, which I reckon this could be medium. Or
the first thing that you return is the spread of the current accumulator.
right, I'm gonna spread the thing at the end. You can't spread at the beginning, so you always reverse your list when you're folding, and then reverse it again.
Okay, fair enough.
So you put the spacer,
Yeah.
because I want the spacer to be after the text, right?
Yeah,
And then
sure.
it goes to text,
Yeah.
and then goes to the rest of the accumulator.
Yeah.
And this begins with an empty list, and then at the end I just do list reverse.
Yes, and you also want to do pop or something like that.
What do you mean?
You also want to remove the last element of the list, because the last element of the list is not going to be a spacer that you don't want. So you're adding a spacer for
Alright,
each
so then
element.
I will
You can check if it's
then
the
I will get
first
the
one.
tail. Because when you reverse it,
Right.
the head will be the last
Right.
element.
Right.
So then I get the tail, and then I move that. Okay, so I guess this. What am I missing here? Line 15. Fold left takes a function, right? And then it returns a list, and in that list we have, of course. Silly me. There you go. Cool. And now we need to turn this list array of list, and then reason react.array. Cool. So now we have a detail component that will take a bunch of paragraphs, which is a list of strings.
Yes.
And it will turn them into the thing that we want.
That is perfect.
So we should be able to replace this.
Yes. And just turn the text into a list and put each sentence in different item.
Right. And I guess, this is gonna be painful.
Why so?
Just the syntax for making lists is just gonna, I think it might be a good idea to split this list into by new lines, for example.
Right, but that's exactly what I'm suggesting. The whole point is that these are different paragraphs each.
Yeah, exactly, yeah.
Right.
I just was trying to figure out how to do it without
I see.
without having to do it myself.
Yeah, I figured out. Yeah. Now I understood.
String, I don't remember utop, string, split, and char. I guess I can redo this. Split. Nope. Str. Come on, seriously?
Mm-hmm.
So BiCodeScript doesn't seem to, it has its own API for handling strings.
Yes.
That seems to return an array of JS strings.
Mm-hmm.
So array to list, and then our listed map. I guess we can first do array to map. Should be faster. And here, I don't know if there is a JS string that will function to turn it into a regular string.
Do you prefer to just do it manually, the list? I think it's better faster.
Yeah.
We don't need to have all the text if it's inconvenient.
But you know how it goes. Ta-da! Yeah, I guess we can do this. Cool.
Neat.
So now we have different paragraphs there.
Perfect.
So the next level will be to put all of this together into something that adds the margin on the left.
Correct. So now we create a content component that is going to be an organism, or it's at the organism level.
Right.
Right now we're not doing any differentiation. And this content component will simply have a row with left to right, to which we're going to have to add a spacer that matches the
Right. Okay. So
that
we have a
matches the
spacer.
other size. Yes. It will probably not match, so we're going to have to do a bit of a hack of adding spacers until it matches.
That's okay.
Yeah, and then
Let's start with 2 and see what happens.
Yeah.
And then we have detail.
And then we have the detail. Yeah.
And
That's-
detail will be parse text.
Yes. Cool. And then we use that one. Awesome. So just keep adding.
Oh, this is great. This just becomes really boring work. You know
Yeah.
what I mean? Like,
Yeah. So of course, this is if we were to have specified at the Figma level. Yeah, we could introduce XXL and so on. I think the problem we have now is that the value we have of this space, the amount of space we have, we don't have it defined anywhere. It's just the combination of the size of the title plus the size of the spacer in between them. We should have formalized that, like at the layout level. So in the layouts we have this spacer on the left. That is the correct way of doing it. Now we are just trying to align it more as a hard code.
I guess that if we had proper layouting primitives, we could also have been able to say that aligned perfectly, at least to my eye.
I think it's a bit. Oh,
I got 0.
I think it's a bit far to the right, but it's okay.
How dare you say that? Yeah, I think you're right. I think this is a little bit to the right.
Yeah, but that's fine. There are also font rendering things that you will actually start 1 pixel to the right.
Yeah.
It's fine. Good. So
Interesting.
you mentioned center aligning. I have to say that is not within the framework, let's say. I don't have a center alignment concept because we usually don't do that. But we can do for covering, in this case, is put a block around this entire thing.
Mm-hmm.
Set the block to be a fixed width, and then let's do the regular center alignment that you do with margin 0 out in the parent.
Yeah, we can try that. Okay, so here we do width and we do
700.
700 pixels.
Yeah.
We can get rid of the div now.
There you go.
Mm.
So now we just need to do in the wrapper we need to do like a div with either flex alignment or margin 0 outer, like an extra wrapper, right? We need to.
I guess we could do a row that has an alignment center.
Right. I mean, yes, you can do that. If you want to introduce the concept of center alignment to a row item, we can add that.
So here's something where OnCamel shines. Adding new parameters with
Cool.
default non-optional values.
Cool.
You don't need to modify anything else.
Cool.
So we can just say if this is going to be a row.
Yeah.
I think it should be across the whole of the screen, right?
Yep.
And then the direction will be left to right.
Yes.
And then the alignment would be center.
Yep.
Then we can just say row.
Yes.
And it's gonna type check as an error because we don't have that yet.
Yep.
But now we can just say alignment.
Mm-hmm.
And of course we can just
combine.
combine.
Yeah. And if it's not defined, we don't set. We just make an empty thing, right?
Exactly.
Yeah.
Switch and then alignment. There are much better ways of handling this, but whatever. At this point, I want to get it up and running. And this would be right. If the alignment is sum and it's center, only if it's center, right?
Right.
So I can say anything else will be empty.
Right.
No, I guess, sorry. If I define this, then the type system will prevent you from putting all the things that are not center in there.
Okay.
Flex.
It's it's align items center, I believe. It's either that or justify content. It's 50-50.
So this is there. And this is here.
Might be missing in the parentheses one more parenthesis.
Extra comma.
With 100% doesn't hurt.
And
To the row.
to the row.
Yeah, we probably need to set the default of with 100%.
When we center things.
Yeah, maybe. The other option is that is justify content. let's try that before doing the width. Yeah.
So we have this one, align center, align items.
Try justify content to center.
Oh, that's a different property.
Yes.
Yeah, justify content.
Cool. It's 50-50. Cool.
Nice. Okay, this is very, very nice. I think that for having started with a Figma sketch, right, of
Yep.
what we wanted it to be,
Yeah.
there's some quirks here and there, right, but we
Yeah.
kind of went through this and defined both the pages we wanted to build and
Yeah.
also what exactly will compose this page,
Yeah.
all the way down to having a design system implementation in the abstract
Yeah.
that enforces certain rules,
Yes.
and also having an implementation of that design system
Yeah.
that works for CSS and React,
Yeah.
that we can look at and we can actually use.
Yes.
I think this has been really, really good.
Yeah.
We definitely need to do another one where we dig deeper into layouts,
Yes.
trying to understand what are the options there.
Yeah.
How is it that we can use, for example, yoga layout from Reason, right, and the type system perspective,
Yeah.
to essentially encode more constraints into our design system that
Yes.
include layouting constraints.
Yes.
It will be really interesting to see that.
Yeah.
But I think for today, this is really, really good. I would be happy to call it a day now.
Yeah, I agree. I think it's. I think that all the tweaks that we have to do for this to go to full TLDR, some of them might be interesting, but most of them are just work.
Right.
I don't think they're going to be adding a lot of extra information around how to use the system. I think most of the levels are incorporated. And I think that when you see at the atoms and primitives that we use, like this row primitive and other primitives, a question that might come up is, why are not those like commoditized? Like, can't you pull those from libraries? The answer to that is that, and we probably will have them as libraries. It's just a matter of verifying that they actually cover enough use cases for them to be useful. So right now I'm suggesting a lot of things that we are kind of building to some extent ad hoc, that it's only because some of them are still at the hypothesis level, but they should become open source libraries that we can reuse. And then a lot of these things that are now just kind of convention could become a framework.
Right. Very, very nice. I wonder how much of what we've seen today applies directly to other frameworks, not just React and CSS,
Right.
but for example, Reverie, as we were seeing earlier today, right? Definitely includes a lot of primitives in here.
Yes.
I guess in source it has a components, UI components library that has clickables and buttons and inputs and so on.
Yep.
And all of those right now, as far as I know, they're pretty raw. They let you modify most things.
Yep.
So they are kind of begging for you to put constraints on top of them. You know what I mean?
Exactly.
It's like it's the constraint that gives you the freedom to move fast and do other things.
Yeah.
But of course, that doesn't have to be part of Reverie.
Exactly.
It could be a completely different library that builds abstractly on top of it.
Yeah.
And it's kind of interesting to see that you could build a library for building design systems,
Yes.
right?
Yeah.
That gives you this, let's say, DSL, design language.
Exactly.
T.
So there is a DSL. Some of it we encoded into types.
Right.
Some of it is encoded into React primitives at the maybe even Reverie level and so on. And some of it is completely in our heads right now.
Yeah, exactly. Yeah.
So that DSL could be formalized completely. There is no theoretical reason why it couldn't be formalized completely.
Right.
We are having some gaps here and there that we need to bridge. But I feel that we personally, but as a community, the people working on UIs are bridging those gaps one by one. So I don't think it's too far away the time that we actually can have that DSL being directly in a type system, where, like in ReasonML, when you have that encoded as a set of types that you use together, or a separate small domain language that you compile.
Right.
Like
Precisely.
or even like from that same DSL you go to Figma and to React or things like that. Like there has been already attempts, some of them partially successful. So
very interesting to know.
Yeah.
All right. I guess let's commit this stuff first.
Cool.
It's gonna be a big commit,
Yeah.
but oops. All right. Live stream number 2. Okay, let's say first MVP of design system with Xavier Villa. Don't look at my password. You looked at it. I couldn't type it. We're gonna put everything in there. There's quite a few components we've written. That's about 500 lines of Reason code in a few hours.
That's it.
Interesting.
We had some boilerplate for each of the components.
Yeah, that's true. That's true. We copy pasted a lot of things, and the design system was already built. I mean, to the extent that the type level constraints were already present.
Yeah.
Okay. I think we can call it a night.
Yeah.
I want to thank everybody that was present and that helped us build this. Well, thank you, Fernando, for coming. As always, it's a pleasure. Anytime.
My pleasure.
We will schedule something else for the third design systems part.
Cool.
Absolutely. Not necessarily next week, but in a few weeks for sure.
Yeah.
So we do some more research as well.
Exactly. It's not going to be related to TLDR.
No, absolutely. It's going to be more of a general thing. We might do something else entirely. I think it helps to have a use case.
Yeah.
So maybe we can come up with a use case. Or if you are listening there and have a use case, that'll be great for us to have as input. This video is going to be available at Reasonable Coding, the YouTube channel, which you can also access via the brand new... I don't know if I have it around. Yeah, I'll do it again because I think it's so much fun. If you go to lambda.tv, right, it will take you straight to the Reasonable channel. You have to type the lambda though. So if you have a lambda nearby, then great. If you don't, well, get one. And if you find yourself in the channel, subscribe and look at some of the videos that we had in the past. They're fun. Also, if you're on Twitch and you like what we're doing, then either subscribe, leave some tokens. People are leaving these tokens. I don't know what they are, but Pixel Hero, thank you so much for 100 of those things. They are CSS. I hate them, but thank you for them. And if you do have a Twitch channel, just feel free to host anytime or do any reruns. This has been Reasonable Coding. I hope you liked it, and as always, stay reasonable. See ya.